Okay, so this is your quiz. This is your last quiz. We're gonna do this together. It should be like 3 points, but you guys have to do the hard work. I understand. Then you guys are with information. They come through along the way. Okay, so sometimes when we go through and we divide by the smallest, we end up getting numbers that are like 1, 1.5, 1.2. For our ratios between our elements. So if that's the case, we have to sit there and figure those out, try to get them to the whole number. The way that we do this is we would multiply them by another number. Let's say we had that phosphorus at 1, and then chlorine was at 1.5. Right? So in this case, since 0.5, what can I multiply 0.5 by to give me a whole? Multiply by 2. Right? So then if I multiply this by 2, I have to multiply this by 2. I multiply both of them by 2. So this guy becomes 3. So then my empirical formula would be P2 at 3. You guys see that? Okay. So I'm going to give you this little table. So if I have 0.2, what can I multiply that by for me? If I have 0.25, if I have 0.333, and if I have 0.5, okay, if I have 0.6667, two-thirds of the 2. 0.75. And then 0.8. Okay. So if it ends, yes, decimals sometimes. So if it ends in those numbers, that's what you know you need to multiply it by. After you've done the division by the smallest sum. That's my hint. Usually I have a question for that in advance. This time I was doing it. A lot of times, yeah. Or I'm thinking about figuring something out. You know, it's like, hey, I have this issue with such and such. I need to figure out how to get them to do what I want them to do. So, how can I manipulate it? Okay, you can't just stare at it. You got to think about it. Okay, so I'm going to ask you guys here. What is the first thing that I want to do? Right? First thing that I want to do. Givens. Okay, so what are my givens? 5.32 8 grams of oxygen. Okay,
0.88 grams of
okay,
hydrogen.
okay. So I'm gonna ask the middle here. What is it? What am I gonna do next? Okay, so let me ask you this. This is quantity. It's mass. Okay, so we want to pay attention to whether it's quantity or mass, right? That's going to be very important.
So we're gonna do the G.
I'm gonna. Remember, I hear it was pretty. Tell me what I need to do.
Right, I'm just like trying to figure out the formula like from yesterday, so like you're gonna do the grams divided by the moles. Or
Moles,
the
okay, so we
right?
need the molar mass.
Yeah.
Okay, so what is the molar mass of oxygen?
16. Oh, molar, wait, 16.
16.
Oh
16.
yeah, stupid, so we look at our periodic table, I'm sorry, doctor.
That's right.
Hey, I started the formula.
Hydrogen is fine.
It's the same thing.
And carbon is
12.
okay. Now this group, well, let's do the math. Gonna do the math for me. The heavy lifting.
Well, for sure you're gonna cross off grams.
Okay. so-
Also.
And then you would divide the 5
Okay,
point.
so it's 0.3.
Yeah.
Of course, it fixed, so. Oxygen. Hydrogen, then carbon.
Divided. So it's gonna be 0.88.
So 0.179. That's good. Okay, so, are you guys sure about that one? The carbon.
No, I got for the carbon 0.4329.
Yeah. Carbon.
I got 0.4329.
Okay,
Yeah,
what
me
did you
too.
get?
Why am I even talking? Why am I here?
Okay.
The smallest number though would be the
Believe in yourself. Yeah, believe in yourself. See that's the thing I'm talking about. You guys get in groups, you're like, oh, they're smart, so. Okay, so what's next?
I didn't do that.
Divided by the smallest.
I put the
Two smallest.
Yes, more than I love my kids.
Oxidation smallest. Divided by 0.3330. One oxide.
So you don't think it's a 0? I did it too.
0.330. Point 66, that's it.
2.645.
2.6, especially big, so. Said 2.645.
45.
Yeah, and you got the same, same thing. Yeah. So you get 2.6669. So re-enter in your calculator. What's that?
I wrote for the grams that were given. Just 0.881.
So wasn't that those little mistakes that we were talking about? Yes,
Why are we?
because that's the smallest number, right? And you want to get it all relative. You want to try to get it so that you have all relative to the smallest one, right?
So 0.8.
Okay. So if you divide it by itself, that's going to give it 1. And then everything else that's greater than that, we're going to have numbers that are greater.
Okay.
What about this last one?
1.3. Oh my God. Okay. Great. Inside it.
What's that?
Oh, 1.3.
1.300.
Yeah.
Okay. So.
Do you round?
Now what would I do?
Do you round to make it a whole number?
No. What did I say? What did I just talk to you guys about?
You multiply it by.
If it was 0.1, that's close enough, right?
Okay.
But if it's 0.3, that's not close enough. So you have to multiply it by,
So
if you look at that side over there, what are we multiplying it by?
So for 2, for the second one, wouldn't it be by 3?
So we multiply it by 3. So we multiply everything by 3.
Oh,
Okay.
okay.
So if we multiply everything by 3,
No. You say everything is the number we got, right? I thought we just-
everything, no, all of the numbers. that you got.
Oh, okay.
If I do 1, I've got to do them all, right?
Okay. Oh, I see what you're saying. Me too.
I know, that's what everybody wants to do, but then it's way off because
Yeah,
because,
no, it is. It's like just something different.
okay, so if I multiply everything by 3, then my number here I'm getting for oxygen,
3,
3 oxygens.
8.001.
8 for hydrogen.
And then
For hydrogen.
3.9 for the,
That's a 4
oh, it's 4.
4.
So we can round at the end.
Yeah,
Round
because
it.
if it's 0.1 or less, you can round. Okay, so if it's 0.1 off or less, you can round. Okay. Round up for 0. Okay, so then my empirical formula is,
So when it be,
so we always use carbon first. That's the lowest electronegativity.
oh,
So 4,
O3. Oh, sorry.
hydrogen, oxygen always goes last. It's 4 like.
So it's
eight, and then
Okay. Yeah, see
so
it?
it's alphabetical order.
It's about
It's a
electronegativity.
bioelectronegativity.
Oh, I'm tired.
So, but actually, carbon and hydrogen are really close, because I think carbon is actually a little bit higher. You always put carbon first.
We could use this to help
That's
us
right.
out.
Yeah. Okay, questions, concerns? Cash.
I mean, I get it.
Okay, so you guys see how this works, you know?
Yeah.
Okay, and you see the distinction between what we did yesterday, right?
Yeah.
It's just a slight difference,
Yeah.
right? Okay, so that's gonna be really important that you guys pay attention to that. So don't just automatically round. I used to do that, man, I was like, man, I know I got this right. And then it's that, oh boy, oh yeah, way off. And then when you do it in lab and shit blows up, and you're like, oh, why did that happen? You know, you're like, oh, that explains it. You know?
So now we're gonna do this
It's only, okay, again, if you have numbers, pay attention to your numbers. If your numbers is, no, if your numbers are, let's say you have a 1 and you have a 1.2, right? Then that 0.2 is enough of a difference that we have to multiply by something, okay? If it's 1.01, then you can just round, right? So if it's less than 0.1, we can round, okay? If it's greater than 0.1, right, is 0.2, is 0.3, is 0.4, right? Then we're gonna have to do this, okay?
Okay.
You guys got that?
Yeah.
Okay? Because it makes enough of a difference that it would change the chemical formula. Okay? So that means, okay, so I know there's a tendency. We have this very, very high tendency of just going through and doing the calculations. This means that you're gonna have to think a little bit. Think about what it is. Okay? You gotta think about it. Okay? I know it's troubling, right? We don't like to think, we just like to do, right? You're like, I get in my car and I go, I don't even think about it, right? Oh, I know.
Your car. We're a little bit. I just like
So did everybody write that down over here?
Yeah.
So that's why that's important, right? Okay, questions? So then, the question that you guys have to do, piece of cake, right?
Yeah.
Okay, so I'm gonna add it a little later.
We just put it there in the classroom.
What was that?
I said, we just put it in the classroom.
Okay, well, you guys, everybody who got this down, right? You guys, I will give you an opportunity to upload this, right? So not,
Can you repeat what you said about those special numbers that you put to the side?
so these special numbers, they help us remember what we need to multiply it by, right?
Yes.
That's all they are. They're to help us remember what we need to multiply it by. So you want to take a look at your number, right? So if we look at our initial numbers, it was 1, it was 2.66, it was 1.3, right? So immediately, that tells me this guy was 1, right? After we divided it by the smallest number. Okay, this guy was 2.66. What am I gonna do? I'm gonna multiply by what? 3, right? Because 0.6667, oh, I multiply by 3. If it's close to 0.3333, I multiply by 3. Yes, ma'am.
So if you have one that's 0.25 and another one that's 0.3, which one would you multiply by?
Multiply by both, right? So in other words, you'd be multiplying it by, if it's 0.25, you're gonna be multiplying it by 4, and you're gonna be multiplying it by 3. So you're gonna be multiplying it by a total of 12.
Okay.
Okay, Dr.
Yeah, by 12.
Everything would be by 12.
You multiply everything by 12, because then that gets rid of both of those, right? Does that make sense? Because at the end of the day, you want all of them to be whole numbers. Okay,
So if all three of them were greater than 1, you would have to multiply all 3 by whichever one.
well, if all 3 of them are greater than 1, you fucked up something, right? Because that should be, because one of them actually divided by the smallest, it should always be 1, right? So that's a clear mistake, right? So if all 3 of them are greater than 1, right? Then that means that you messed up, right? So that means you might want to go back and check your answers. Because one of them, after you divide by the smallest, should always be 1. Does that make sense?
Yeah.
But let's say we had 4, right? And 3 of them were greater than 1. Then we go through that process, right? Okay. Good questions. Yeah, I like that. I like it when you guys think, right? But doesn't it make more sense to multiply it by both numbers? Because one is a 3 factor 3, one's a factor 4, right? Okay. Questions? Concerns? Can I erase? Okay, good. Okay. Thought process working. Still early. My brain is like, clicking, but it's not clicking. Okay. So let's say we have. Change this around.
So I have a question that I already asked it in my head, but I just want to get it out there. So it's proportional to each other, right? Like what I,
That's
the
right.
way, okay. I'll
That's
ask
right,
it then.
because it's a compound, right? They're together.
Yeah.
They're gonna be proportional. That's actually a good
What-
question.
I was gonna ask if one of them were
Okay.
off by 1, and if you had to use 2 of those on the side, the special numbers.
Okay, so combustion analysis. What do we know about combustion? What do you guys know about combustion? I'm gonna get CO2 and O2. Are you sure?
H2.
H2O. And we need O2 for the reaction. So we have a hydrocarbon, we're gonna use oxygen, and we're gonna get CO2, and we're gonna get hydrogen. Water. Okay. So here, the X and Y represents the coefficients. that you're gonna have over here, but they also represent the subscripts. Okay. This is basically true, right? They're gonna be. Okay, so let me give you the rest of the problem. Trying to do it in my game here. It isn't working today, so. Let's do. Okay. So here's your problem. So the first thing that you want to do is find the empirical formula, right? We're going to find the empirical formula very similar to what we've done before. So I want you guys to sit there and think about it, and then we'll work through it together. It's also part of the tip quiz, right?
Oh, that is okay.
It's still part of the quiz. It's part of the beat. Right? 10-point quiz. Part B. 10 points. You get 10 free points. You want to complain about it? No. I didn't think so. Well, if you showed up and you did the problem, you get
15.
no, you get 10.
30.
10 plus 10.
Okay.
10 for each one, right? What was that? CO2 is 0.8.
Okay.
saying, what is when you like uniform and molar mass is thought to be between 40 to 50%. But it's exactly how I was gonna find the mass of the CO2 and H2O, and then like do like. And it says 50 to 46.
Just more about it is smart, right? Put it all in there. All your eyes on. Yeah, it's like stress the white hairs. I don't have that. What should be some distribution real quick? This first, then that is.
Go to Chem.
Yeah, she can.
So I just, if you want, you guys want to, I got the action on them because
I wouldn't have gotten it done. She said that. I was like, so. Like clothes. Yeah. Dude, I had it. I was like, I'm not. I'm so sorry. Okay. But on cat, right? What you doing? You guys both did. You guys both did.
really?
Yeah. She said that I didn't do it.
Tell her.
Right here. No. Why can't it be like 200 plus? Good. That's just here.
Okay, so let me give you a quick example. So if I have the empirical formula. Formula for a compound is C2H5. Okay, and then I tell you that its molar mass for this compound mass of 87. Okay. Can you tell me what the molecular formula of the compound is? The way that you go about doing that is you have the empirical formula, right? So you would calculate the molar mass of the empirical formula. So what would be the molar mass of C2H5? Carbons do I have? I have 2 carbons. That's 2 times 12, 4. And then I have 5 hydrogens. 5 times 1. Okay, that's 29. Okay, so if I have 29, that's grams per mole. So then if I have 87 divided by 29, that's going to give me my ratio of the molecular formula to the empirical formula. So what is 87 divided by 29? Okay. So then what I would do is I multiply my empirical formula by 3. So okay. Can you simplify it? Yeah, but that's you've already got the empirical formula. You divided by 3, it goes back to the empirical formula. This is the molecular formula. Okay, so you don't want to run in circles, right? That's just extra work. Okay, and there's a tendency. We have a tendency of doing that. You're like, okay, now I got it. Now I need to go back to the empirical. Exactly. Okay, so knowing that, I'm saying this, right? Because I've given problems where I've given them the number of moles here, right? Because we know we have to get to the number of moles, right? I've started off with students with the number of moles. They go back and they do the calculations and they get the number of grams, right? And then they start all over again. So they've done the problem like 3 times by that point, right? So pay attention to what you're given.
I don't understand.
I think it's just a slide.
I'm just kidding. I gave you the set.
Oh, it's like.
Yeah.
Yeah.
I wrote it over here. You guys can see it. And it will- So that was just an example, so that it would help you with this problem.
Oh, okay.
Okay, so you guys ready to do this problem?
That's exactly that on the bottom.
Okay, can I read this right here? This has nothing to do with this problem. It's just an example. Yeah, so this one was already good. Okay, so let's look at this problem. How are we gonna start? Where we're gonna start at? Okay, so we need to get the molar mass of CO2. So the molar mass of CO2, we have 1 carbon, and we have 2 oxygens. So that's 16 times 2, that's 32, plus 12, so that's 44 grams per mole. And then of water, we're also going to need the molar mass of water. Two plus 16. Okay. So how am I going to use that?
Would you do 1.44 grams of H2O?
Okay.
Over 18 grams of H2O.
Okay. So you said 1 mole of H2O. And then that's 18 grams. Okay. So then that gives me moles of water, right? What is it that I want? Do I want moles of water? But I'm looking for, I want to know what this is, right? That hydrocarbon, right? So we know that a hydrocarbon is composed of what? It's composed of carbon and hydrogen, right? So if it's composed of carbon and hydrogen, I need to get hydrogen, right? Because I need to figure out my empirical formula for that hydrocarbon. So how many moles of hydrogen are in 1 mole of water? This is what you're saying. I want you to think about what you said. Think about it before you answer again. Okay, how many moles of hydrogen are in 1 mole of water?
2.
What did you say over here? You say 2? That's right, because we know for every 1 mole of water, we have 2 hydrogens, right? That's quantity, right? So then we have 2 moles of hydrogen. Okay, now what you were giving me the number of particles, right? You're going back. We don't need that right now. Okay. Can I go ahead and read this part? Everybody got this down? Okay, so if you do the math, let's get.
Is it?
Yeah.
Yeah, it is.
Okay.
Okay. So do the same thing with our CO2.
Dr. Henry, can you get a better marker? Please.
I can't. I can say my red marker sucks.
Yeah.
If you guys can
Just a little bit. No, that one's fine. Yes.
Is that better?
Yeah.
Oh my gosh, you did it. He put it on there. I was doing it on the calculator.
Okay, so for every 1 mole of CO2, how many moles of carbon do I have?
1 is 1.
You guys can.
0.06.
Okay, so which one is smaller, carbon or hydrogen? Carbon is smaller, so we're going to divide everything by carbon.
It's 8.
Probably Saturday night.
8 for hydrogen.
Wait a little bit, go hang out somewhere there. You're all set.
This is a real big typo, but that's all right.
Awesome. Okay. Hydrogen. Right.
What happened when you go in your head? You mess it up. 4 times greater than that. Okay. So our empirical formula is going to be C H E. Crazy number. Okay. So if we're going for empirical mass, so
Steps. Okay, steps.
so that's 12 plus 8, which is 20. Right? Okay, so 20. So if it was 20 grams per mole. So what can I multiply it? That would multiply this by so that it would fall into this range. Multiply it by 2. That would be the only thing that can multiply it. So it would be we know that this would not exist in the actual structure, but for kicks and giggles, this would be our answer. Okay. You guys see that? Saw how you use the molar mass to determine our molecular formula. So this here's our empirical formula.
Double. Okay.
So to determine our molecular formula, we knew it fell between the range. So what do we multiply? Its molar mass, the empirical formula is molar mass 5. That would fall within this range. Multiply it by 2, right? If we multiply it by 3, that would be 60, right? Okay, so right here are carbon 8. This is its molar mass for the empirical formula. Okay. So since I know that it's 20, give me that look. So
Oh, no, I'm hungry, so.
you're hungry? Okay, so that's a hungry look. Okay. Let's get that. So if I multiplied it by 3, that would give me 60, right? 20 times 3 is 60. And I know that it has to fall within the range, right? Does that make sense? Until you get that range, exactly. So what whole number can I multiply it by so that it will fall into that range, right? So if it's 20, it has to be, because it's between 40 and 56, right? So it has to be 2. That's your only possibility. Okay, you guys get that? Okay, good. So let's see if we can make it a little bit harder, right? Just a little bit harder. Okay, so let's say we had something like this.
Yeah, I just don't know.
Okay. Fix this. 1.44.
Very little cook.
Just change it.
Add to this problem here. Yeah, part C.
Oh, parts. And then you change 1.442. So if we do it again, we do that problem. They're the same. Like sociology.
What do you learn?
Wait, no, she said this up to check. Those are her. What's another one that you do, like, forever? If I have never seen it. I don't know, he just.
So.
No.
A little bit. But your brother looks like your dad. Brother looks like my mom. They do. As many persistent. We brought the microbes and the cousins from. We say that the side of family. It doesn't look like things. It doesn't know why. Oh, wait. Yeah, we're doing it.
That has really long, I have the cell phone.
Roadies and Really?
My girl never learned that. But did she like your little brother? Yeah, like she like tries so hard to get my attention. That's so bad. That's not like issues though. Like she has like, what is it? It's because my dad's a weak guy. That's just 5 older women. Like my his father, sisters and brothers. Like that's exactly that. But there's no.
His other two sisters.
Cheated on my cousin's birthday. They got divorced. She wouldn't get. She wouldn't tell me. They asked me why. These ever since that day.
Yeah.
My grandma put it against me too.
Sorry, I made a mistake.
Because I always
How much the compound? Did you work?
Just turned 19 this year. And her school decided.
Okay, I'm gonna give you a hint. Law of conservation. That's
So
right.
even the wording. When we
What was that?
I read the whole word problem. Word problem.
Yeah. Okay, where am I going to start?
That's crazy.
With my CO2. 0.88 grams CO2. This part. Grams. 2. Two. Now, oxygen, because we have two sources of oxygen, we have the oxygen from the air, and we have oxygen for our compound. That's going to be important. Okay, so we don't care about the oxygen in the from the air. We care about the oxygen that's in the compound. Okay, and if we take a look at all of the oxygen that's here, we're getting oxygen from the air and the compound. But I also know that I have in my compound, the total mass of my compound is 0.640, right? So that means that if I get the amount of carbon and I get the amount of hydrogen, I should be able to subtract to figure out how much oxygen I have. So we'll save that for a second, and one extra line here. So since you brought that up, we need to know how much carbon we have in our compound. So the way I get the mass for carbon would be multiplied by the mass. So we know that 1 grams. Okay, 12 times 0.02. Yes, everybody got this down? Down. So we're not like that part. Think about this board chart. This big. Okay. And for hydrogen, okay, water. Grams hydrogen per mole. Hydrogen in the water, yeah. Hydrogen. Heavy lifting. Numbers in those 0.08. Okay, so if we multiply that by 0.08 moles hydrogen. And that weighs 1 gram, 1 mole. Mass. Said it right. 0.08. Okay, so my carbon, so my total compound weighs 0.64 grams. This is my compound. Okay. The law of conservation says what I put in, I got to get out, right? So if I'm taking out the carbon, that's minus 0.24 grams of carbon. And then if I'm taking out my hydrogen, 0.08 grams hydrogen. So then what has to be left? My oxygen. Which is okay. So then I get my oxygen. So that's going to be 0.32 1 mole of oxygen. How much does it weigh?
6
grams. So then I have
Yes.
So then I'm going to divide it by the smallest, which is the smallest. We're going to look at the number of moles. 0.02. So we divide everything by 0.02. One. One. And then this is two. Okay. So then my chemical formula is going to be H4. Oh. Okay. Questions? Concerns?
Started off at CO2, trying to figure out, when we figured out the flow for carbon, we go straight into oxygen.
You have to figure out how much hydrogen you have to go to. So you have to get the hydrogen first. Right?
This is what I did, but.
Well, but you made the assumption, right? So what you're saying is that all of the oxygen that's in the compound is coming from your compound. All the oxygen in CO2 is coming from your compound. You make that assumption. You just got lucky, right? You can't make that assumption. So, because that's not always what it is. Okay. Questions? So I gave you guys 3 examples of potential test questions, right?
Test question?
Yeah, have you looked at your exams?
Oh, nothing else down there.
Okay.
When you first go to the exam, I was like,
I was like, he's doing drugs or something.
Okay, are you guys
He got the
feeling?
wrong class.
Feeling it? Okay. Now, are you guys seeing how everything that you guys have done from the beginning, from the simplest definition, molecule, right? Everything that you've done from the very beginning has built up to today, right? So,
should just have to know.
yeah. See, we should just start it here, right? And then you got it all, right?
why can't we just start it from the beginning?
Oh, I'll do this. Okay, next time, my next class, I'll start here.
Yeah.
So you guys gotta make sure that you're not in that next class, is what you're saying?
What next class?
What was
I was
that?
just thinking of having a quick one too.
Okay. So let's get some notes.
And that's all of the quiz, right?
No, there's one more. There's
Oh.
more
There's more for this quiz? Okay.
for the exam. Oh, for this quiz?
Oh, yes, for
For
our
this
quiz.
quiz, this is all. Let me
Okay.
set it up so you guys can upload it. So you
I'll
can
do
get
that.
credit.
Yeah.
And it's also, I also use your quizzes to keep track of who's here because supposedly I'm supposed to keep roll. Horrible. Supposedly. So that's why I get it again. Make sure you upload your quiz. Make sure you upload your quiz. Plus, you want to get your points. Yeah, it's not worth it. Quiz 11.
Yeah.
So you will have one more quiz. And we're done with all your quizzes.
I thought you said this was our last.
What's that?
We got like 2 more days left. Next week.
You have 1 week left. That's what I said.
No,
you
you
said
said
last
this is our
quiz.
last quiz.
Oh, this is your last quiz. Okay, so if I said this is your last quiz,
Yeah.
this will be your last quiz.
Yeah, I mean,
No,
so
yeah.
you said it like in the beginning of when you were writing it down.
Gotcha.
Need more points?
I heard this was our last quiz. Finished.
That is true.
This is our last quiz. Let's make it up.
Hey, I do want more points. Never mind. Next time. Next class.
Okay, so I won't give you a quiz. Last time you got carried away.
Me too. I just honestly, she just put it back my neck.
If you guys.
It's there, we can't see it.
Yeah, I see that it popped up.
It's amazing.
Can't submit anything.
No.
It's there.
Okay.
Okay.
Okay. So we have a little bit of a dilemma in terms of time.
What?
Just relax. So I have a lab plan, technical plan for today. We can get the lab done, but then you won't have one of the major parts that you're going to need for your class. And so that means that on Monday, you'll have like double lecture and you have presentations, right? So if we do the lecture today, then on Monday, we can do the lab and then you guys do your presentations when you come back from break.
We're done.
Okay, and then on Tuesday, you'll do a lab and we'll do a lecture.
Before the exam.
What was that?
Lecture before the exam.
It'll help you, the lecture for the final. Okay. Okay,
More labs. We have labs just now.
just, you have 2 labs left. So, and the last 2 labs are the best lab. And then, so you won't have, so normally what I would have you guys do is the next 2 labs and you have a formal report. You guys aren't gonna have formal reports for this. We're just gonna turn in what you guys. So you could actually finish the lab in class. Okay. Is that fair?
Yeah.
So what we're gonna do is, I'm actually gonna let you guys go for break now. And then when you guys come back, so you guys have a 20-minute break, so at 9:50. 20 minutes. 20 minutes.
Appreciate it.
This is because my coffee doesn't hit. 20-minute break, and then when you guys come back, you'll start the lecture. I have 2 lectures to get into. So it's very tough. Okay. Sorry.
That's the only thing.
Sorry, go smoke cigarette, and you said like break, and I was like, oh wait.
I don't know.
Wait, what happened?
I'm a sweet part.
Crunch time right now. That's why.
Girl, we broke it.
Right? And it's great.
That's true. So, yeah, so you're gonna figure out. So then.
The blind vanilla latte.
Are you
Oh,
scared
so I
of
would just-
Starbucks?
She's getting. We have to stay here.
Yeah, I'm like, go pick up.
If I place an order,
I was,
if
I knew I
am-
was missing a step, but I was like, no, no, like,
So I'm like,
it was missing.
And then now you figure
Oh.
it out.
you want something?
I don't know what you're going to do, but now you're figuring out how much.
She does, but she's taking one.
No. Me.
Very cool.
Just give me a drink. I don't know, like.
And then-
I'm so
I'm good to go.
And I'm not on shift. Not till 2 o'clock.
Because then-
Ew.
The brown chicken.
No, I'll just get a strawberry, I'll see, I want to keep it.
What,
Emily,
basic?
Cassandra.
But add peach juice. Just
But I was
I don't
gonna
think
say-
we have it. I know a lot of stores have it out.
Oh, what?
Peach juice.
Oh, the strawberry.
You know what? I'm.
What did you want?
Like a strawberry. Oh, I love how you're doing
What
it.
did you want?
A strawberry. I'll see.
With lemonade?
Yeah.
It's for Zyra, right?
With Cyrus?
Syrup?
Yeah.
With, sorry, you want?
Just text everybody and everybody text me.
Okay.
I need my license.
I don't know. Because,
I didn't even bring mine. I didn't bring my ID, my card, because I do license.
I thought you had both. Oh, la tengo en.
La tengo en yo. No.
I just earned 25 points.
Oh, I know. It's sitting. I'll see. How'd you guys speech go?
We haven't done it, but it's
Yeah.
only, 6 minutes.
That's why I put the charts. Maybe to help you get up here.
I remember one time she was having a 2-minute speech, right? Dude, I did like 30 seconds. That was it's because I get nervous and I dropped
I
fast.
thought I.
It was literally
And then-
the first
and then I
one.
had
What
drawn
what
like-
grade in there?
I missed it with the 90 something.
Because it was a 5-minute,
How much percent was your expectation?
like the percentage. of
Ours
our
is 45.
percent of our grade, our speeches.
You don't remember? Ours was 45% of our grade.
We literally had a 5-minute speech
And
and like,
it
was
out of
like
3.
No, I had done it in my class, and you know why I would mess up? Because I would see the phone popping up, so he'd be recording me, so I'd be like,
the freaking dog.
No, but
so then
participation
she
wasn't
turned
too
and she's
bad.
like, why
Me
are
at the end?
me?
What?
I hated it so much. I thought it was gonna be fine, but I wasn't. I was so.
It's for the group presentation?
Yes.
No, and see, so ours, everyone left our group, so it's only 2 of us.
Oh, everybody dropped.
We had like 6 people in our group, and then 3 people dropped out first. So never showed up, and then the other one had to drop last minute. 'cause of family emergency.
I was so mad because I had to go there. Obviously, I would get there at like 3:30, and it would end till like 7. So I got there right earlier. so I could practice my speech. And then she like after like right after she says, guys, I'm not gonna make it. I'm like, are you kidding me? I drove you for a
That was us on what Monday. We got there at 1 and we left at 1:30.
I know I was
We just went to.
I was like the
Say
way
hi.
I come ready.
Oh, yeah.
Yeah, we were the ones who got the insurance.
The first one, the second one, people.
I just hate that she takes forever to read the fucking work. Yeah, class is over today and she just started grading today, well, yesterday,
Yeah.
at night.
Yeah. Just, I think he's joking too much, that's what we do.
I have a teacher like that.
Dr. Henry, is this your only class?
This semester, yes. Usually I have 3.
Really?
Yeah, our teacher,
She's juggling a lot.
So it's
It's
Louisa.
more.
more.
Yeah.
What class is this?
Communications.
Why do I even have to take that class? Is it like a requirement?
Yeah, it's
Let's
a
do that.
requirement. It should be.
No.
Yeah, it should
No,
be.
I haven't.
Yes. Communications, you guys don't realize, it is, oh my God, it is so
But I feel like it's,
valuable.
I
I
feel
feel
like,
so judged in there.
I do too.
You should be. Gotta get used to that,
I feel
right?
like it's mostly like speaking in front of people, like, I feel like I'm not gonna do that in my job.
You wanna bet? If you're planning to move up in the ranks, then you're gonna do that. If you're planning to stay at the bottom, then you don't have to worry about it.
Well, because
Right.
I feel
I
like
feel like you
regardless,
should-
you have to interact with people and socialize with them. You have to have a conversation. You know how to like act normal, I guess. Well, yeah, because
Yeah.
if not, like you're gonna start freaking out. Like, what do I tell them?
Cause I feel like I'm okay with talking to someone one-on-one, someone new, but when it comes to like presenting in front of
Oh,
a
no,
bunch
it's
of
gonna be
people,
what I
that's,
can't.
that's
No,
when
you
I
gotta
start to
get over
tense
that.
up.
Because
I
really,
can't.
if you guys are planning to move up in your careers, whatever career you are, you're gonna have to be able to talk in front of people. Sometimes it'll be groups of 10, sometimes it'll be, the audience. Sometimes you have to sit there and make announcements to a whole, like if you guys are going into nursing or you have to make a,
Shipwrecks.
yeah. We had a, when I was doing an internship with Delta, and the nurse actually had to come into the emergency room, make a public announcement, and make it coherent enough so that people understand it, and then had to translate it to Hmong because the people that were in there were all Hmong. So there was this outbreak. Somebody had made some bad meat or used bad meat. They got it for real cheap, and they had this festival. All these people, it was packed. So she had to make an announcement telling the directions and stuff like that, and she almost passed out. Poor nurse. I felt so bad for her. She almost passed out, right? But the thing was that she got up there, she made the announcement, and people didn't still understand what she said because she was so nervous. Right? So that made more chaos to the situation. Had she been up there and said it clearly and concisely, it had just been done. Because literally all they wanted them to do was they were setting up a tent because there's so many of them. They were setting up a tent outside. They just finished setting up that tent, and they wanted to move them that were in there outside so that they could start doing testing out there. Because there were just so many people in the air. It was a disaster. They had to get the police and everything.
I
because
love
there
to
was
talk, I just can't talk in front of people. I never shut up, like, ever.
But see, that's the thing, by you doing it, by you taking a class like communication, you learn how to utilize that love to talk, And most of you guys love
We're
to
supposed
talk,
to
I hear you guys.
Cause we know each other.
Oh, we didn't know
you
her, we
have to
just
look,
met her.
Yeah.
but you have to look at it as everybody that's out there, just kind of switch it up. Oh, I know, I'm not worried about it. And don't think of it as them judging, and even if they are, who gives a fuck, right? Well, at the end of the day, it doesn't matter.
Never gonna see them again.
Cause I feel like if they're my colleagues, I know them, like, I think I would be okay.
Yeah.
Cause I know them. I'm
That's the
familiar.
one thing I liked about the testing more. Since I didn't know anyone who accepted all of it. And I was
Oh,
like,
that
I don't
still
care.
makes
I don't
me
know these
hella
people. I'm not gonna
nervous.
see them again. So.
No,
The
that's what
first-
makes me, I don't know why that makes me more nervous.
It makes
if I
me
don't
more
know them.
nervous not knowing people in there.
But then it's like,
Yeah.
because
We have
they're
we have
older,
Ivan,
you
we
don't
have
have
Ivan in that class, and I feel like I always catch Ivan's eye. I'm like, let me look
But
somewhere else.
sometimes that's to your benefit, right? Because then you look at them, you're like, hey, and then that's a face of comfort. I always, when I scan the room, I look for the faces that I feel comfortable with. People that make me uncomfortable. I had this instructor, and she was actually my advisor for graduate school, and she would sit there and do anything that I would say wrong. She would do that, right? And it would drive me fucking crazy, right? It made me so nervous, and I get so worked up. So then I got in the habit of just
No, you did
not
very
looking at her at
Right,
all, right?
yeah,
So I
no.
look behind her, I look, you know, so then it wouldn't bother me so much. And then I would actually do a much better job because I'm not worried about her making those faces, right? So, and even though I knew her, I knew what she was gonna do, you know, just like, but it would just work me up inside. So I get worked up and then I want to address her immediately, you know, like, what the hell, what, you know, like,
Why you make those
exactly,
faces?
why are you making those faces? What did I
What did I
forget?
do
You
wrong?
know? And so,
Yeah, well, the last presentation we did, or presentation, I was looking at the teacher, she's like, back, she's like, moving her hands, I was like, oh my gosh.
She's
You
like,
know, when
And
I
she
was
just tells you to
gone,
go and she just claps like silently, like, oh my gosh.
when I would talk, she'd look at me, then I'll stop for a second, like, oh, why are you looking at me? And she's like, okay, like, continue, you know?
No,
like,
and it's hard because I'm not good at memorizing things like that. And like my
Yeah.
partner, she like memorizes word for word.
no,
Like,
she's good, her partner's good at it, like, she's like
but
memorizes. the
I
whole
think
thing.
memorizing a speech word for word is the worst possible thing.
Because
It
you
sounds
you
scripted.
focus on that.
That's right.
Whereas
And it
if you
sounds
just
scripted.
go, you're gonna improvise as you go.
Yeah, and then she was like,
Yeah.
word
Like,
for
what do I say
word. Like I
next?
was looking at, I was listening to what she was saying. I was like, that's exactly what was written on our document. Like
Yeah.
word for word.
Yeah.
I was like, oh my
Yeah.
gosh.
But it does sound like a script, like.
Yeah.
And she
like
was
in a
telling
play.
me to like she was telling me, she's like, okay, should I didn't memorize the word for word? I was like, no, I was like, I'm not gonna do word for word. I was
Yeah.
like, what do you mean?
Because what tends to happen is that if you get anybody that will interrupt you in real life, then you're always gonna get interrupted. Especially if you're telling people stuff that they do not want to hear, right? Then you just break down. I mean, and then you just stumble and you're like, you lost where you're at, and they get you all worked up, and then you're all talking. But if you sit there and you get the key points and you convey the key points,
Just go off of that.
that's right. And particularly if it's a presentation, you know, a slide presentation, don't read me the slides. I can read, right? I just need the key points. That's a waste of your time. It's a waste of my time. You know, so you want to convey the key points. Oh yeah, these are the things. You know? And then you use it as a way of giving you guidance, but you don't use it as, you don't want it as a crutch. You know?
Right.
Let's see.
I also also online.
Yeah.
Oh, I think you were calling.
Oh, they just say Dr. Henry.
No. So do we really have to take organic chemistry?
A lot of you
Depends
guys
on-
do. It
I think
depends
I
on
do.
the program that you're getting into.
Because they
Your
never
program-
mentioned that.
Your program, most of them require organic chemistry. You may get into one that doesn't, but a lot of them do.
So
So
I would
what-
do it just in case.
What class are you teaching next semester?
I'm teaching general and I'm teaching 2A.
I need
So
2A,
You're,
if
this
it's,
is
if I
2A.
pass this one. Oh, no, wait,
You need to be,
2B.
yeah, we're trying to get it offered in the spring. If I
Right.
have enough of you guys, and so what I'll do, I'll pass it around a petition.
Yeah,
If I have enough of you guys that are interested in taking it, then,
it'll be open.
yeah, we can try to.
Wait,
get
what's the
it.
difference between this and that one? Like what's
Uh,
different? If I pass?
It's, so you know that little part of organic chemistry that you had?
Oh, no, it's this week.
You're gonna have a
Yeah, I'll
full
do it.
semester of that, which it tells you how things are reacting and carbon-based molecules don't behave the way that others do. Right? And it's a lot more complicated,
Oh,
right? And so, but the majority of it is memorization. Like 99.9% of it is memorization. So you're gonna do a lot of memorization. There's very little math.
I like the
Very
math
little.
parts. I'm really good.
Yeah, I like the math parts too. That's
it's
why,
just
yeah.
Go, go, go.
I'm horrible at making myself sit down to memorize stuff.
yeah,
Right.
you can't do that.
I hate it, you know, but I'm like, but it's part of it, you know, it's one of those things that you gotta do. So, wouldn't you say?
That's why I hated organic chemistry. Yeah.
I don't think any of it, because you guys, I'm bad, and I'll admit, I put my bias, and my bias, who you're taught by affects your bias, right? And so I tried to make it positive, but I hated organic chemistry too, right? That was like, exactly, but you get it, and then when you're doing the lab, it's really cool, right? Because then you're smelling the chemicals, or you get the crystallization. That's the cool part, but sitting there and memorizing the equations and, okay, so these electrons are being transferred here and this, it's kind of cool when you start getting it, but to learn the tricks first and sitting down to memorize those tricks are the hard part. And you got to put that time in.
And of course, there's so many things that affect the reaction that you have to take
That's right.
consideration.
Yeah, because it's the solvent, you know, it's the temperature, it's the, there's so many different ways that you
I thought this class was.
Yeah.
When I signed up, I was like, I got all these equations.
But it is hands-on. I mean, it should be, you guys really. Okay, so let me tell you what task happened. Right?
We look at the chemical on the screen.
Normally, you guys would be 4 days a week. And the way I had it set up, it was 2 days a week, it would be a lab, 2 days a week, it would be lecture. Now, the way that they have it set up now is that you guys meet 3 days a week, right? And so I was trying to set it up so I would do lecture for 2 hours and then lab for 2 hours. But 2 hours, sometimes it's not enough for lab. 2 hours, sometimes it's not enough for lecture, right? So I need that 3 hour, right? The 3 hour gaps. And then they also have it set up because I have to give you guys a break, right? Boss says I have to give you a break because we're over 3 hours. So you have to, right? So, but they didn't factor into a break in the schedule, right? So then.
They still give you that, it goes
Yeah.
between, it goes between your lecture and your lab.
Exactly.
You know, like, it's not.
Yeah.
Specified.
They decided, and I get it, you know, I get why they did it, because they wanted to save you guys money, right? So you guys having to come to campus 4 days a week, they don't have to come to campus 3 days a week. Right? So they tried to do it that way.
I know, I went negative on my account just to make a guess. I was telling her.
Yeah, I sit there, I calculate how much. So in the spring, I went to Salinas, right? So Monday, Tuesday, Wednesday. So Monday, Wednesday, it was here. Tuesday, Thursday, it was Fireball, and Friday is the Salinas. And so in the fall, I'm gonna have Monday, Tuesday. And I said Monday, Tuesday here. No, Monday, Wednesday here. Tuesday, Thursday, Fireball, and then Friday.
Like, why can't it be like a consecutive, like, the Monday, Tuesday here? There.
Yeah.
Why can't it be like, why is it like you're here, one day, here, there?
Yeah.
It's so confusing.
Yeah.
Like, I would be confused if I was in my.
It's bad because there are some days when I don't think that I go to the car. I'll be going to the
Don't
laundry.
look at me.
Then
Don't bug
some
me. At
days
least
I have
don't
meetings,
look at me
right?
like.
So when I have meetings in the morning,
Yeah, I
then
know.
that means I have to be here, right? And then I have to.
You're crazy.
I'm weird like this.
Are they revert?
No, it's gonna be
Yeah.
nervous before 20 minutes.
Yeah, for Fireball, we do. So this is my home campus, so I don't get reimbursed.
Oh.
So if I have to
We're
come
branching
here,
out to.
and Salinas, well, West Hills is a part of Salinas, that's another thing. I don't get reimbursed for that. Just altogether, I was spending over $1,000. Yes, yeah. So that's.
Over $1,000.
Over 1,000.
And that's what these grass prices now, or that was just, oh yeah, because it was free,
Yeah, it was pretty.
but it wasn't as bad.
It wasn't as bad as it was. this
Yeah.
summer. Yeah, so, yeah, now it would be well over.
Way.
Yeah, so I'm thinking, right, I'm weighing the factors. I want to get a car, and I put it off because I don't want to spend money on a car, but I want a car, right? And so, but I need to figure out a way, and then now if the interest rate's going up, then I'm paying more for a car. I should have thought I was gonna get it. You know, I got my car fixed, I'm like, yeah, I'm not gonna waste that money, I'll just save up for it. And then something else came up, and then that's the way it always happens. You save up, so.
I had a car, the car that I have now, like my other car was starting to break down.
Yeah.
And
And everything's double space and I have like space.
so when I was
double
calculating
space.
all
I
the
did
parts,
double
whatever needed to be fixed, it was
So
just.
you
a
don't
Mine's
down
an MLA format.
for a new car, so it's like, I'll just get a new car.
Yeah.
Because there's no point. I
Yeah,
was breaking down all the time, I had my kids in the car, the AC wasn't working, and I was like, so I needed a new car.
yeah.
At that time.
I know, I know what you're saying. 'Cause I'm right there with you.
I know, but I cried because I was not waiting, so. I got so many tickets in my car.
No, we believe you.
I know, it's true.
Imagine so small the classes.
Because we understand stuff more.
They're funny, with their funny drinks.
Did you text me? Well, you didn't. Okay. No, but I was like, I think I could do it.
You have to go.
Oh, look at her. She's like, I could do it. Oh, what did you get? Ooh, that smells so good. What did you get? They gave you how much Swiss on a stick? A panini? Oh, you should try the chicken and bacon panini. I see that
That
one.
one's so good.
So good. But it's just isn't it like an apple piece? Apple piece?
An apple.
Yeah, like the
You
blend.
just have to look into it.
I know, I'm done.
I know the sauce is like on this.
Look at these boys on.
Always eat. I like to think.
I think you guys are actually.
The chicken.
You think so?
Oh,
Never
mind. What time did everyone leave?
I hate formulas.
Like 9.
I got here on time and I drove by the speed limit.
9:15.
No,
It was 30. It was 9:30. It was like 9:30.
Yeah, it was a
So
little bit
50.
after my.
So they're not too serious.
Well, no, it was
They
like-
have 3 more minutes. left, so.
Do you want to look into that real quick?
3 more minutes.
I'll go get that computer. Because I'm gonna do it then. I should send it to you guys, just individual one.
Dude, I'm like, no.
Oh, you have it on your phone. I'll email it to you, yeah.
We could do that mesa, huh? Yeah, we
Oh,
could.
yeah.
What's the-
Not enough time of day.
I should go home and one more time, I didn't finish till 11. I was like, are you kidding me?
2 more things. Got one of them is almost done. The bulk of it is done. It's just, yeah, sitting myself down. and forgot to finish it.
You know, the worst.
I did 3
I was so
last.
stressed. I was gonna cry. I was like, why are you crying? I was like, leave me alone. Don't talk to me.
No crying.
I cried.
We're crybabies.
Like, I know. I'm like, I got it right. Ah.
Going
Watch me start crying right now. Tell me don't
Going
cry.
home, I had a mental breakdown.
It was awful. I can't say full.
So great. All of it.
All the mentality. Tears.
That smells nasty, honey. That smells gross.
Is it the Swiss?
That one doesn't smell
You
that
said
bad.
Swiss.
I usually
The
get the
turkey
double.
pesto. This is disgusting. I don't know how people.
I usually get the double smoked bacon one, the croissant
yeah.
sandwich, but there's no stores have been having it. No Starbucks
There's like a
stores.
shortage on it.
And I'm like,
No, I'm
what
not
the
even
heck?
playing.
I
And
know
then
last
we're
time
gonna-
like, me
we're
and
gonna
Cassie
get a-
got one.
Yeah.
Cassie was the one that got it and I had to get a different one. She got
She
the
was
last
all
one.
mad.
I was like, I wanted to cry.
We're gonna get a shortage on lemonade, on the pineapple drink, on the peach,
Oh, you work too?
and then on some of the sandwiches. No, the one in Kettleman, but it's for like all the Starbucks.
What the heck? I
You
really
ready?
wanted to get my coffee in.
Yeah.
I'll leave this mic on.
You know, it's funny. I woke up early and I started looking at.
Funny.
Never. You're like, I'll just answer this real quick.
Henry, what time is your class for the 1 day I'm doing next semester?
I'll pronounce it.
Are you teaching Bible too?
Yes, I'm teaching the fireball and so.
I was almost track.
Yep, you guys are it. Yeah, well, and I'm taking a class, and then, well, that isn't true. There's another thing. I also I have a couple students that are taking the MCAT this next semester. MCAT. It's the test to see if you get into med school. And so I have 2 students that are taking the MCAT, so I have another course that I do once a week for them.
Would you like that at E? I went to one in Texas.
I did one for the T's,
Uh,
I guess 2 years ago. So if there's enough interest, then I'll just stay here.
Well, it depends. What apply to your graduate office? But I doubt it. It's 'cause I don't- To 18. I don't know myself, but I don't. So I'm working with them.
I haven't done it yet, I just got it.
Where they can help. But it depends where you're- I know 19 and all that, but I haven't.
So on the safe side, you only have 2 tries to pass it. It's very much.
I applied. and I got it.
It's a
I literally, yes, I applied and they're like, no, sorry, after. Maybe I wanna work at the one at Leamore Centers. And every freaking thing that I was like, they were having calls. Things down. But I could get the one here.
You applied it? You applied? I feel like most of the chemistry I think is on it too.
So it's after the free class.
That's good.
I was like, oh, girl.
Oh, I get it.
Yeah, I know. I thought I was gonna have something like that.
I've been to it too. I went to. Well, they were both my dad's. Like, they would go. God, we picked the one way for here. Yeah, I will start crying. I cannot go because of that. Even though I didn't, I wasn't close to them, I still started crying. I don't know. It's horrible. It's like, I don't want to. Did it! Yeah! It's about these, and done.
We should have recorded that TikTok.
Aw, freaking typing too.
Everyone said. Everyone's here.
Not a scene in here?
Huh?
Okay, I would have been drinking. I don't know what's wrong with it. You're there. Yeah. I didn't say anything. I think you're for years.
Oh, yeah, I did that one.
I was about to say, oh my gosh. I wrote the
You know what?
straws.
I wanna freaking know.
I literally had them in mind because the lady in front of me, she had no sense. So I was like looking at that. No, like nothing. No, nothing. Absolutely.
That you?
No, but it was a lady. So, and the lady asked them, oh, do you want straws? And she's like, no, thank you. So she left. I was like, okay, I'm gonna get straws. They always want straws. And get the straws. I was like texting everything when like, oh, by the way, that orders are. I guess I forgot. I think I have it. And I was, no, I haven't. I really was barely even walking out of here. I like really pushed the door close the time. Okay. And I forgot the straws. I'll go.
Oh, no, it's just one.
That's a beautiful person. And boom. I'm not ready. Go back down. How?
Chapter 9. Is ready, chapter 9?
Maybe.
Where'd you get a copy from?
Yeah.
Oh, what is
You know,
that?
I teleported.
You liar.
Huh.
You got it like that.
What's that?
You got it like that. As a teacher, I just did.
What's that?
What do you get? No,
No
what's
idea.
that? Yeah. Like what
Was it nitro?
Oh, that isn't an action. That's
A shaken
it's a
espresso.
shake and espresso, yeah.
Cool.
Not the barista.
Bartista.
Instead of barista. Aren't you a bartista or something?
Yeah, same shit.
It is. It's focusing. I think.
Are they gonna cover gases?
Yeah. Briefly. Very, very briefly.
Is on oil?
No. Hopefully, yeah, there's one question.
I think that all the coffee's down here.
I have some.
I was thinking about doing that, just stapling it.
I have a lot.
Okay, so Yep.
Can we have more drinks over here on the side?
no, you gotta have more drinks. Yeah. Eat all your drinks, and you should be eating in lab. You know the rules?
I'm hungry. I
Oh,
even
I
told you I was so
understand, but-
hungry.
You didn't tell me anything when I started eating?
I wasn't paying attention. Now I'm paying attention.
I'm sorry, what chapter is it?
9. 9.
Guys, it's the end. No.
Nueve.
I might just be nice.
Yeah, I know my number. It's to know them up to 1,000. Now I can't tell you. I know millions. You know, I can't say it right.
Me either, it's okay. I can't say bartista.
It's a barista. Why do you keep saying bartista, dude?
I like it like that.
Bartista.
Dude, I can't even say names. One time, a person's name was Chelsea, I called her Chalisa. Okay.
So, you guys are very familiar with charges. You guys know how a light bulb basically works, right? So we have this light switch. If we have electricity flowing, through, if our electrodes are connected with each other, then we have light, right? If the electrodes are not connected, we have dark, right? So we have the switch that basically goes up, goes down, goes up, goes down, and it just connects that electron. So that's what you guys are seeing here. The electrode is connected. So if we have a solution, we have been characterizing ionic compounds as are they able to sit there and carry charges, right? So if we have a solution that is ionic, then that means that the charges are able to break up, right? They're able to split up into their positive and negative charges. Now, if they're able to split up in their positive and negative charges, we can use this to sit there and conduct electricity, right? So they act as if that electrode is connected to each other because the charges line up and they carry the electron through the system, right? Because you guys know electricity is based upon the movement of electrons, right? Okay, so if we have a compound that is covalent, like water, or a compound that is covalent, like alcohol, right? Those guys, they will break up into positive and negative charges. And so they won't conduct electricity, okay? So if it doesn't conduct electricity, it's called a non-electrolyte, okay? Meaning that it doesn't conduct electricity. If it's able to conduct electricity and is able to do it well, it's called a strong electrolyte. If it's able to conduct electricity, but it does it poorly, it's called a weak electrolyte. Now, the difference between a strong electrolyte means that you have almost complete separation. That means that the ions completely separate from each other. So that positive and that negative charge completely separate. Where in the case of a weak electrolyte, you have a lot of them that will stay together, but you only have a couple of them that will actually separate. Okay, so in the example of our strong electrolyte, we have copper to chloride. Well, copper to chloride we know is an ionic compound. When we put in water, it will completely separate. Okay, so here you can actually see this is the water molecule, you know, the Mickey Mouse ears, water molecule. So the water molecule will surround the chlorine, and it'll also surround the copper 2 ion. Okay, so because of that, those guys will be separated from each other. They'll charge. So water is kind of like a home run. It's able to break up that ionic compound. Now, a covalent compound, water is not able to break it up, right? It can't break it up into its components like you can get with the ionic compound. Okay, so then in the case of a covalent compound, it's not able to sit there and separate, you know, the hydrogen and the carbon. You don't get charges in that case, right? Because you don't get any charges, it won't be able to conduct electricity. So covalent bonds, covalently bonded compounds won't conduct electricity, where ionic compounds will. Now, acetic acid is a weak acid. That basically means that it doesn't dissociate completely. It doesn't separate completely. So you get one or two of them that'll separate, but the majority of them will stay together. So they kind of act like they're covalently bonded because they're staying together. They're not separated, okay? And so because of that, you get weak conduction of electricity, a weak electrolyte. Okay, are you guys with me so far? Okay, so definitions. Electrodes are the two little things, the conductors of electricity. So when we put the electrodes together, we're able to allow the electricity to sit there and go through. Electrolysis is that process of moving electrons through an electrolyte, right? So you're doing it through a solution. Okay. So this again is just showing you that if we have potassium chloride, we put potassium chloride into water, it separates completely, we get conduction of electricity. Okay, so strong electrolytes will completely dissolve, completely dissociate, right? So they're going to separate completely. Weak electrolytes, they only partially separate, right? Only a little bit. Okay, and non-electrolytes don't separate at all. Okay, that's clear on that? Okay, so this is basically what happens when you get dissociation or separation or ionization. Okay, so sodium chloride. So we have solid salt, right? Now, when you guys see solid salt, it's together. As soon as we put it in water and we stir it up a little bit, what happens? It dissolves, right? So when it dissolves, it's actually separating until it's ionic components. It separates to that Na plus and that Cl minus. Okay, same thing happens with the copper 2 chloride. When we put it in water, it separates. Okay, this is just basically showing you that process. So this is that solid that we initially put in, sodium chloride. So this is the chloride ion. You see how water surrounds it. And this is the sodium ion. Okay, now if you look at how it surrounds it, the red represents oxygen, the white represents hydrogen, right? So who is facing the sodium ion? Oxygen or hydrogen? Oxygen. So you can clearly see that the red is all facing the sodium ion, right? Now who's facing the chlorine or the chloride ion? Is it both? The hydrogen. So the hydrogens are facing, right? So the white, right? Because we know that water has that special characteristic where it is. Oops.
Oh, shoot.
Where it's going to be partially negative and partially positive, right? It's going to form that dipole, right? You guys remember what I mean by partially negative and partially positive? What was that? So is it not necessarily ions, because they're not ions, they're partial, right? So you're sharing electrons, right? You're still sharing electrons, but you're sharing unevenly, right? So if they're sharing unevenly, one side is going to seem like it's really negative, and the other side is going to seem like it's positive, right?
What is it called?
It's kind of like, okay, well, let's put this in sexual terms, right? So if you're straight, you date, let's say if you're a guy, you date a woman, right? If you're a woman, you date a guy. If you're gay, you date guys. Guy dates a guy. Okay. Now, if you're bi, you date both together, potential dating both. Now, when we talk about people, right, there's ranges of people, right, that are both bi. You have the ones that are like 50-50. Okay, yeah, you know, that's kind of like non-polar. They're sharing evenly. Oh, yeah. One day they go on a date with a girl, one day they go on a date with a guy. Then you have the ones that are like, oh, yeah, you know, I like guys a little bit more. So they're leaning a little more gay, but they're not gay because they're not only dating guys, they're also dating women, right? And then on the other way, we have where you have they're dating a woman, and then they look like they're straight because they're with women most of the time, but occasionally they go and mess around with the guy, right? So there's a range. Okay, they're not completely one way or the other. So when we talk about these charges, it's not completely positive and negative. It's like, oh, you're a little bit positive or you're a little bit negative, right? So you're not really gay, you're a little bit gay, right? If you're bi. Do you guys get it?
Yeah, I get it. What is it called though? What is it called?
Okay. So when we talk about this, oxygen is partially negative, right? So that means that the electron is spending more time around that oxygen than it's spending around the hydrogen, okay? So in that case, we could say like oxygen is kind of like a little bit gay, right? But it's more negative part of it than the positive, okay? Do you guys see the similarity? Yeah. Okay, I know it's a stretch, but okay. So, but if we were talking about being ionic, either you're gay or you're straight, right? That's it, right? So either you're gay or straight, that's what your choice is, okay? So that's what it's one or the other, right? You're positive or you're negative, right? You're gay or straight, okay? But if you're talking about that partial, oh, you could be somewhere in that middle, but you're not committing to either way, okay? And the reason that you're not committing to either way is because you're not giving up electrons. You're not giving it up, right? If you're not giving it up, you can't commit to either way, right? So Okay, you're still sharing. Like, oh, we're gonna share this, okay? You guys with? Okay. Now, because of that, this partial positive and partial negative, we can orient, and that's what happens. The oxygen or the water orients itself so that the oxygen is facing towards that positive charge, right? Because oxygen is partially negative, right? And then here we orient towards our hydrogen orients towards the negative charge, right? Because hydrogen is partially positive, okay? Okay, so again, if we dissolve chlorine, copper to chloride in solution, right? Water is going to cause it to dissolve. Who's going to orient towards the copper 2 ion? Hydrogen or oxygen in water? Oxygen, why? It's more electronegative or it's going to be partially negative. That's right. It's going to be putting the electrons next to it. That's right. Okay. And so that means that who's going to be orienting itself towards the chloride ion? Hydrogen. That's right. Okay. Because it's less electronegative. It's giving up those electrons in a sense. You know, oxygen is getting a little bit more. Not giving up. It's you get a little bit more than that. Okay, so what I'd like you guys to do is write the dissolving equation for potassium sulfate. Is that what you keep doing this?
Yeah. I don't like.
No, it sounds like somebody is clean. Oh, goes free.
Yeah, it was her.
Okay. So you got some answers for me? Okay, so what would be the ions for potassium sulfate?
Okay.
So how would I write the equation? Equation.
H2SO4 with the F.
Finish writing the equation.
Will we add water to it? Or this is one way of doing it?
Yeah. I know.
I gotta figure out a way to get this to work out. Having to run across the classroom. Okay,
Yield 2 potassium. Do you always do that? I think it was about water.
that's right.
Plus SO4 with the 2 minus charge. Oh, and then another aqueous.
Are we missing?
You ever seen the positive charge on the K?
Okay. I
Is
mean,
it
a positive,
negative charge?
It's a positive.
but you have to put the charge.
Because it's broken up into ions, right? You're telling me that when we put it in water, it splits up, it dissolves. So it's ionic. But when it's a solid, it's together. So it neutralizes its charge. Okay? Now, what about the second one? Let's see.
This is when you always mess with me because one minute will put.
Consistent. If it's a solid, no charges. It's together. When it's aqueous, right? It's separated. It's going to be broken up.
You always start with a solid and then solid.
Okay, so what about the next one? It says write the ions present in the solution for calcium nitrate without writing the dissolving equation. So what ions would be present? Okay, so calcium, how would I write that?
And it has a positive charge.
2+, right? And then
There's two of them.
3,
Yeah, but there's two. Two of those.
technically there's 2, right? So that would be all we get.
Without dissolving, so you just
Yeah,
write it for what.
so you just write what it is, right? What's there. Okay? You guys good?
Yes.
Okay. So when we talk about acids, we've been talking about acids. We have strong acids and we have weak acids. Strong acids will completely dissolve. Okay, now the way that we depict an acid, if you guys take a look, we have. Okay, so we have, for the acid, it's written as H because the hydrogen ion is going to be let loose, right? In water. So then we're going to form what we call the hydronium ion. So what happens is that H plus grabs a hold of, grabs a hold of water. Sorry about that.
What is that called?
No,
Yeah. Grabs a hold of water, right? So because it grabs a hold of water, I'm like, Jesus Christ, that scared me. Like, man, I didn't realize I was so strong. Wow. Okay, so it grabs a hold and so it's holding on. And so this is what makes an acid so toxic to us is because that H plus just grabs and it's like, and so it will grab onto our skin that's on the surface. So it literally will be transferred to that water. It'll grab onto the water that's in us. It's a bad thing, right? So that H plus forms what we call now the hydronium ion. Okay, so this is what's really happening, right? Okay, but often the way that we write an acid is, I write it up here. This is what really happens, and this is how we do it. Okay, so the H plus goes to the water, that Cl minus is now. Okay, that's what really happens. Now, the way that we depict it is. Okay. So the second way is the way that we depict it so that we can keep track of everything, right? When we start doing this, it makes it a lot harder to keep track of it. You guys understand the difference, right? Means the same thing, but there's that slight difference. Okay, so we say, instead of saying HCl plus water, we say HCl AQ. Because it's water, right? It's in water, right? And then we say, okay, we get the hydrogen ion. That represents the H3O, right? The hydronium ion. Yeah. Okay.
So either one is correct.
Yeah, either one is correct. Okay. Now, if we have two hydrogens to give away, so like in the case of sulfuric acid, what's the chemical formula for sulfuric acid? Here, I'll put it on the board. So you guys can see.
H2SO4.
H2SO4, that's correct.
So the hydronium acid, like,
They're the same thing.
Okay.
The hydronium ion,
Separate, but like, check.
yes, because it's in water,
Yeah.
and so literally that H plus just attaches to water. Okay, so what do you think is gonna happen here? Two. H3O. Plus. Now, this happens in steps, right? The first one is gonna happen easy, it's gonna be quick. The second one is gonna take a little bit longer, but it will happen, okay? So the way that we write this is so this is called, it's considered polyprotic. Protic means proton. So if we look at H plus, how many electrons does H plus have?
None, right? The first takes it away, right?
That's right, it has none. It has no electrons. 0 electrons. How many protons does it have?
One?
It has 1 proton. And how many neutrons does it have?
One? No.
It has 0 neutrons. So it's called a proton. Our proton is being donated, right? So we call it polyprotic when you're donating 2 protons. So if you're donating 2 H pluses, what are you donating? 2 protons. Okay, so it's polyprotic. Okay, so if I'm donating 3 protons, it's going to be polyprotic, right? Poly meaning more than 1, right? Okay. Diprotic 2, polyprotic 1. Okay, questions? Concerns? Okay, so again, if it's a strong acid, you're going to get completely dissolved. So you're going to split up into your ions. If it's a weak acid, talk about, these are 2 examples of strong acids. Okay, strong acids. If it's a weak acid, like HF. What does acid be called?
Hydrogen
Chloride?
Hydrochloric acid, that is correct. Hydrochloric acid. So in the case of hydrochloric acid is a weak acid. Okay. Now hydrochloric acid is a strong acid. So you'd assume that hydrochloric acid would be a strong acid too. But what happens in the case of fluorine? Fluorine is so strong that it doesn't want to let go. Have you ever met a couple where like the boyfriend or the girlfriend is just so dominant, they do not gonna give you an example that would be totally inappropriate, but they do not let the other one have any independence at all.
La toxica.
What was that? I didn't say anything in there, so, but that would be an example.
They're always together.
Yes, so inseparable
Ah.
couple, right? Where one of the members of the couple is very dominant, okay?
I just call it like you see it.
So in the case of that, in the case where you have one of the couples totally dominant, right? That's kind of like fluorine. Fluorine takes control of the situation, right? And so fluorine is like, no, you can't go to the bath. No, you cannot go with me, girl. You're gonna stay right here next to me. If I go to the bathroom, you're going to the bathroom with me. If I go, go in the kitchen, you gotta go in the kitchen with me, right? So that's the way fluorine is, right? So it's not gonna let hydrogen loose, right? So,
Nah, we don't fuck with.
so what happens in that case, it stays together. Now, normally we would expect it to go, we'd expect it to let hydrogen go, right? Now, it only lets hydrogen go every once in a while.
Very light.
Yeah, I keep grabbing it too. It's an acid, right? Anytime it's an acid, it's considered to be aqueous, right? So, again, hydrochloric acid. Okay, so if you look at this, hydrochloric acid basically is doing this. It will find a point of equilibrium where it can go a little bit in this direction, but it's mainly going back in this direction. That basically means that we have more of this present. Okay, we have more of it together than apart. Okay, so it's kind of like that couple where you have one of them that is so dominant that they don't let the other one do anything. Okay, where hydrochloric acid is like, chlorine is like, bitch, bye, do what you want to do. You want to go out, do what you want to do. So exactly. So you have two different cases. So in the strong acid is the lowercase. They're totally separate. That's totally independent. They dissociate. Strong acid.
The top one's pink, right?
Yeah. Okay. So we define things by a major species or a minor species. Okay. Major species, in the case of a strong acid, this is what's happening. So the major species would be the ions. So that means that when they're together, this is the minor species. Okay. So in the case of a weak acid, who's going to be the major species?
Well,
Together or separate?
Separate. No.
Or weak acid?
Yeah.
Together. Together is going to be the major species. Major basically means the one that you're going to have the most abundance of, right? I just told you that you have more of this happening in the case of hydrochloric acid. They don't want to separate. Hydrogen, fluorine says, no, you do not separate from me. You're staying right next to me. So this here is going to be a major.
Oh,
I'm
take
gonna
the
give you-
reactant and the.
I'm gonna tell you how you. Okay, so when we talk about acids, the way that you tell if an acid is strong or weak is partially where they're kind of located, right? The ones that are going to be more commonly known to ionize are the ones that are going to be more electronegative, right? Except for chlorine. Chlorine is too strong, right? He's too much of a bully, right? So he's not going to want to ionize, right? Meaning separate. Okay, he's like, no, 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 you keep your butt here until I dump, right? You're mine until I want something better, right? And so that's the way chlorine is. Okay. So in that case, you're going to have more fluorine that's going to be together, more hydrogen fluorine that's going to be together, then that's going to be separated. Right? It happens, right? Fluorine gets, a nice little streak. Okay, yeah, you can go to the bathroom every once in a while, but that's it. But only when I tell you. Where hydrochloric acid, hydrobromic acid, hydroionic acid, all of those guys are going to be strong acids, right? They're going to be fine, do what you want to do, right? It's because they're able to totally separate or mostly separate. They're going to be like, hey, go ahead, do what you want, right? Okay, so if it's able to separate, it makes it a strong acid. If it's not able to separate, or it's separating really weakly, then it's going to be a weak acid. Okay, so your strong acids are going to be anything that typically ends with IC, IC, right? If it has IC at the end of it, it's considered a strong acid. Except for when it's carbon. If it has carbon in it, carbon always makes it a weak acid. Okay, so carbonic acid, a weak acid. Oxidaic acid, a weak acid. Acetic acid, a weak acid. Right? Can you guys, acetic acid, where is acetic acid found? What do we drink or mess with that acetic acid is found?
Lemon?
Not lemon. That would be ascorbic and citric acid. Vinegar.
Oh.
Vinegar. So acetic acid is just vinegar, right? Yeah. So, do you guys drink vinegar? Drink? You don't drink vinegar? You do eat pickles? So you drink pickle juice? Uh-huh. Yeah, so you do. Right? So that brine that you guys make with the pickles, right? That's just the formation of acetic acid, right? So you guys drink quite a bit if you guys eat pickles or drink pickle juice. I love pickles. Oh man, it's bad. I will drink it on its own. My mom used to hate me because I drink all the pickle juice. Okay, so that is an example of a weak acid. One of the reasons why we're able to drink it is because it's a weak acid, right? And it's not a very strong acid. Even when it's concentrated, it could be it could be a very bad irritant, but it's not going to kill. Okay, so and typically it's about 5% acidity that you guys see. So what we're getting in the bottle is super, super strong. It gives you an idea, but that's considered to be a weak acid because it's a carbon-based acid. Okay, citric acid, a weak acid. You guys drink orange juice, right? Ascorbic acid, also found in citrus, right? Another weak acid. Okay, so carbon-based acids are going to be weak. So if it has carbon in it, weak acid. Okay, if it has ick, it's going to be a strong acid, except for hydrochloric. Okay. Okay, so carbon makes it weak automatically. Okay, so it doesn't matter if it ends with ick or not. If it's OUS, that's going to be a weak acid. Okay, so sulfurious is a weak acid. Chlorous, weak acid. Okay, what about chloric acid? Is that going to be weak acid or strong acid? Okay. Okay, so what is the difference between a weak acid and a strong acid?
A strong acid is
It's going to be more separation than together. Much more separation than together. Okay, good. Okay, so weak acids, they're going to conduct electricity poorly, right? So we showed earlier if I had vinegar, it conducted electricity poorly. Okay, its major species is going to be the unionized, or when it's together still. Unionized basically means that it doesn't form the ions, right? Ionized means that it forms the ions, okay? And then the minor species are going to be the ions, just for showing you up there. So here's an example of a strong acid or a weak acid. So the second one is basically vinegar. So this is acetic acid. So if you guys take a look at it, you have water, but you have it where most of them are together. These are the ones that are separated. So you have the ion separated in one case, but every other case they're all together. Okay, here, this is a strong acid. So this one here is hydrochloric acid. So these guys completely separate, right? You don't have anything that's really together. Everything is separated. Okay. So this is just basically summarizing what we just talked about, but they're giving you actual numbers. Right, so you guys get an idea. So at different concentrations of water, right, we have different things happening. So the more stuff we have, right, we have a little less ionization. Here, if we make it diluted more, we have more water, it basically dilutes completely. Right, here, this guy is mostly together, 9% of it is ionized. Here, 22% of it is ionized. We add more and more water. So to make a weak acid more ionized, we have to add a shitload of water to get there, right? Okay, so hydrochloric, you guys can see the difference. Hydrochloric conducts electricity poorly, where hydrochloric conducts electricity very well. Okay, major species are going to be the ion in the case of the hydrochloric. In the case of the hydrochloric, the one that is together is going to be the minor species, minor meaning less, right? So we have less of this one that's together in the case of the hydrochloric, and in the case of the ions in the case of the hydrochloric. Okay, so these are some of the 7 most commonly known strong acids. So nitric acid, sulfuric acid, hydrochloric acid, hydrochromic acid, hydronic acid, chloric acid, perchloric acid. So both of those are, right? It's also per, typically means it's going to be a strong acid.
So per and ic,
Yes. Per and
except for
yeah,
hydrochloric.
exactly. So if we have per hydrochloric, that goes. Actually, I have to think about that. That might give us a 1 + 1. But I think it's a weak acid still. I think if it's perchloric acid.
Oh, okay.
So I'll have to find out for you for that. Okay. So again, when we talk about the major species and the minor species, so if something is totally separable, right, then our major species are going to be the ions, right? It's able to completely dissolve. Okay. Okay. So write the formulas of the major species in solution of nitrous acid and chloric acid.
His paper.
That's not understandable.
Okay, so nitrous acid. What is the chemical formula for nitrous acid? What about chloris? I mean, chloric
have
acid.
H in front of it.
Or should, because it's an H.
HCO2.
Okay, so what is going to be the major species for nitrous acid? Major species for nitrous acid. You'll give her a kiss later. Or I'll tell her. Okay. So, first one. So, is it going to be together or separate? Together. So this would be our major species.
It'll be what?
Okay, what about chloric acid?
Separates because it's a strong.
So this is our major species. Okay? You guys get it?
How do you determine that? Whether it's
What did I
major
just
or
tell you?
minor?
What did I just tell you?
Whether it can separate or not?
So we know that it's a strong acid. If it's a strong acid, it's going to separate. That's what's going to be in solution.
And that's gonna be the major.
That's going to be our major species, right?
Oh.
So separate means separate. If it's
Right.
strong, separate,
Oh,
right? If it's weak, it's going to be together.
that's gonna be the minor.
If it's weak, if it's together, that's going to be its major.
Oh.
So think about it.
They're two separate, okay.
Yeah, two separate
Got it.
circumstances.
Yeah.
Okay. Are you guys with me? Everybody with me? Anybody not with me?
Yes.
But if that was a whole equation, like if it dissolved.
If they were together, if they were
Yeah.
both in solution, right?
Yeah,
So what would happen is that you have both of these in solution.
yeah.
This is what you would have. So you have nitrous would still be connected, and then these guys would be separated. Okay, in solution, right? So that's the thing about it, right? We're putting it in solution already. It's already in solution. This is what you're getting, right? So that's what's going to be available. So then you add something else to it that would react to it. Okay, sorry. Okay? Does that make sense?
Yeah. At the end of NO2, would that be a negative charge?
No,
No?
because it's together.
Oh, okay.
Right. If it's together, it's still going to
But
be,
if it was separate.
if it was separate, NO2. Yeah. Okay. So I'm going to go ahead and write this equation. If I write the equation down, and we're going to go through this on the board.
That big old one?
That big old one, yes.
This looks so big.
Okay, but before you guys do that, do me a favor. So we have lead, 2 nitrate. If you guys can look on your periodic table packet, there's a sheet that has solubility. You guys know what solubility means? How much it dissolves, right? So if it's insoluble or less soluble, means it doesn't dissolve. Okay? So if you guys look in your sheet, there's a solubility table. Is there something that says lead 2? One of those tables.
I'm looking for soluble.
Okay, you're looking for lead 2.
Yeah, I thought so.
Okay, you guys found that too? Okay, now look at lead 2 nitrate. So look at nitrate compared to lead. So what does it say?
It's soluble.
Okay, so since it's soluble, we know that that's gonna mean that when we put it in water, it's gonna separate. So we're gonna put aqueous, right, next to it. Okay, so anytime that it's soluble, if it's green, right, it's soluble. Okay, that means that it's gonna be aqueous. So when we have that, we put water in it, it's gonna be able to dissolve. Okay. Now look at sodium chloride. So look at sodium, and then look at chloride. It's soluble. So again, when we put salt in water, it dissolves, right? Now look at lead chloride. Lead 2 chloride. Is it slightly soluble? Basically meaning that it's not really soluble, right? So it's pink or orange on your sheet, right? So if it's pink or orange, depending on which sheet you have, right? Then that basically means that it's going to form a solid. It's going to form a precipitate. It's a precipitate. Basically means it's going to come out of solution, forming a solid. And what type of reaction is this? It's a double replacement. That's right. Okay, now look at sodium chloride. Sodium nitrate.
Nitrate.
Sodium nitrate. It's soluble.
Yeah.
So we're going to put AQ next to it. Okay, so that's how you determine if something is going to form a solid or if it's going to be aqueous in solution. Okay, so that's how you determine if something forms a solid or if it's going to be aqueous in solution. Okay, so the first thing that we want to do is make sure our equation is balanced. Right now, is it balanced? Okay, so let's balance it. Shouldn't take you that hard since it's balanced over here. So, take you too long. Is that better?
Leave it. Yeah, good see.
Okay. So we need to balance the equation, right? So we got P, we have NO3, we have Na, we have Cl. So on my reactant side, how many lead do I have?
1.
How many nitrates? 2.
2.
How many sodiums?
1.
How many chlorines?
1.
On my product side, how many lead?
1.
How many nitrate?
1.
How many sodiums?
1.
How many chlorine?
2.
Okay, so what do I need to do?
Put a 2 in front of NaNO3 on the product side.
3. Okay.
Yeah, you can group them
So then that
together.
gives me
2,
2.
2, and then you can put it in front of NaCl on the reactant.
Okay, so we're balanced. Okay, so we got it nicely balanced. Okay, so now this here is called a conventional equation. Conventional, normal, right? So this is called our conventional equation. Sometimes you'll see standard, okay? So this is what we're used to. Now, what's really happening is an ionic equation, right? So a total ionic equation. Okay, so in the case of the total ionic equation, we're going to dissociate the ions. So anything that says aqueous, it's going to dissociate. Okay? So what will be the ions that lead nitrate dissociates into? Okay, the PV, what's the charge on PV?
Oh, I don't know.
Okay, and then we have the nitrate,
Yeah.
right? What is the charge on the nitrate?
Nitrate is gonna be negative.
Okay, and there's two of them. Okay, so the way it works is, I need to borrow two volunteers. Come on up. One more volunteer. Okay, come on up. Now, I'm lead. She's one nitrate and she's another nitrate. Come on up, come on up. Grab my arm. Okay, grab my arm over here. I know, I'm strong. You know. Okay, so now we're connected, right? We're connected by charges. I'm positive and they're negative, right? Okay, now as soon as we get in the water, I separate. Now, are they connected? No, they're not, right? So who's holding them together? Me, because I'm positive, right? So they're going to completely dissociate from each other. So they're going to be like two independent nitrates. So that's why we have two of them, right? We have the coefficient 2 rather than the subscript 2. Subscript 2 suggests that they're together, right? You guys see the difference? Okay, thank you. So
you can't just,
I can't just put a subscript in. No.
you have to add something else to it, right?
Yes, we also have to add to it.
I believe you're gonna do,
AQ, to remind me that it's some water.
you're gonna add another freaking formula, right?
No? What about the next part?
You're gonna do the 2 and A.
2 in A. And what's the charge on NA? Positive. AQ. And then what about CL? -1. How many do I have? Okay. Then on the other side of the equation, this, if it's a solid,
It stays, right?
liquid, or gas, it stays together. That's correct. If it's a solid, liquid, or gas, it stays together. If it's a solid, liquid, or gas, it stays together. Wani, when does it stay together?
Solid, liquid, and gas.
When it's a solid, liquid,
Liquid
or
and
gas. You remember that, okay? So is it gonna stay together?
Yeah.
Okay. Okay, so what about the next one? Is it gonna separate or is it gonna stay together? We're gonna break it apart, so we're gonna break it apart too.
2 and A. Plus NO3. Plus NO3.
Okay. And then we have the charge.
Okay. So this is called the total ionic equation. Okay, so you're splitting it up. Okay. Now we've got the total ionic equation. Have you guys ever been to a party and you see people standing on the wall and they're just watching everybody else interact, talk to each other and stuff like that, and just sitting there?
I'm the
All
person
by
on the wall.
yourselves? Yeah. You're the person on the wall. Yeah. So those people are called spectators, right? Because they come to the party just to watch everybody else have fun. They don't want to have fun. They're people watch. Exactly.
Problems, right?
No, they typically don't cause problems. They don't do anything.
They
Right?
mind their business.
They're spectators. They just watch, right? So spectators are going to be the same on both sides of the equation. So when we talk about spectators for chemistry, they're going to be exactly the same on both sides of the equation. Okay, so help me identify the spectators. Who is exactly the same on both sides of the equation?
I mean, the NO3, yeah.
So we have the NO3,
The 2
the 2Na,
Oh, right, see that?
Yep.
Yeah. The same on both sides.
Because of the.
Oh, yeah.
okay? So because they're not doing anything, right? They're not contributing to the party or anything like that. They're just standing on the wall. They're not interacting with anybody or anything like that. We can just ignore them. You don't even remember them because you're like, were they even at the party? Because they didn't do anything, right? So we take them out. So when we take them out, we're going to get what we call the net ionic equation. Okay, so in other words, all they did was they brought the people that hooked up to the party, right? The spectators, right?
Yeah.
Okay, that's it. So
what-
that is the
what-
net ionic equation.
What would you call the guys in boxes? Like, what's their term?
Spectators,
Spectators?
Yeah.
The guys in boxes.
guys in boxes. Okay, so those are your spectators. Okay, you guys, you got it? Not too hard? Okay, so let's see if you guys actually got it. Ready?
So for the they are the spectators because we brought them down, they didn't change.
That's right, they're exactly the same. Charge is exactly the
It
same.
has nothing to do with being the same on the side, right?
No, it has to do with them being the same, exactly the same on each side. Right, because if you look at this. Yeah, they're exactly, both of these guys are exactly the same on both sides, right? This guy got together, right? They hooked up, so they're not exactly the same.
Oh, okay.
Okay. Okay. So it has to be exactly the same. If somebody hooks up, they're no longer exactly the same, right? They hook up with somebody. Yeah, they're what? They're a couple. Okay, how you guys doing?
Yeah.
Look depressed. Don't be depressed. It's because of your road dogs left you. They all done. See? Okay. You never look depressed. You always look happy.
She's like, no.
And she starts laughing.
On the laughing.
Okay, so let's test this out, see if you guys got this. Okay, it says, when a strip of magnesium metal is placed in iron 3 chloride solution, a magnesium chloride solution results and solid iron also forms. Develop the net ionic equation for this reaction. So what I'd like you guys to do is give me the conventional equation, give me the total ionic equation, identify the spectators, and then give me the next ionic equation. Okay, so I'll just erase what I have up there. I want the conventional. I want the total. And I want the and people started drinking that.
I wanted to break. And break.
Hey, where's that sangria recipe? She's
Did you
trying
say
to
green recipe?
No,
Be-
I
I need
know
it.
yesterday, that's all right.
That's all right.
I'm in that class.
I'll give it to you guys on Monday.
I won't be here Monday.
It depends on, you won't be here on Monday? You should be here on Monday.
That's presentation.
Yeah. Definitely want to be here on Monday, because if you don't show up for presentation, you get 0 for everything, right?
Okay.
So make sure you show
I'm doing it on
up.
via Zoom.
What's that?
I'm doing it on Zoom.
No, you're gonna be here.
I'm gonna make that. It's hot till.
Non-negotiable.
We're having a potluck Wednesday, letting you guys know. I'm just kidding.
Can I bring that?
Yeah, we can do a potluck. After you guys finish the potluck.
I'm down.
Exactly.
We got about
And then I can bring that. We have a
You guys got a barbecue.
It'll be actually
Yeah,
sunny.
yeah.
We gotta go barbecue it up and.
We won't.
No, we should do that.
Y'all are down? For real? Cause we can make a list.
Let's do it.
Dude.
You guys wanna-
Yeah.
You gonna barbecue? You guys are-
I don't know about the barbecue.
I'll barbecue the day before and bring it for you.
Well, I can-
Because
have
it
my
takes a
favorite
while
kind
to
of
barbecue, so.
You guys really wanna do it?
I'm down.
Okay, let's do it.
Someone start a list. Someone start a list now. Pass it over.
Paper list. Paper to read.
Can you finish the part first? He's all like, hey, you guys need to do the equation.
Okay, you guys ready?
Yes.
My conventional equation, it says a strip of magnesium metal.
It's a
Wait, so it says it,
metal.
a magnesium chloride solution results, so is that what we're trying to write
That's
out?
what you're making, right?
Right,
The
okay.
product. Okay,
Okay.
It's a metal.
okay, so help me through it. Help me write the equation. It's a metal, so it's a metal, it's
So it's
Mg.
Magnesium?
It says, okay, wait, I want you guys to read it. It says a strip of magnesium metal is placed in, okay, so what are my reactants?
So it's gonna be the magnesium,
Magnesium. So what is the magnesium metal? What's the symbol for magnesium?
Mg.
Mg.
Yeah.
No, it doesn't have charge because
Oh, because it's
it's
gonna be.
an element of it initially, right? It's an element, right? So there's no charge associated with it when it says metal, right?
Oh, yeah, we're going to conventional.
So cute, girl.
Okay. So, and then you said we have iron 3. What is iron 3? Fe.
Cl. Chloride.
If we're writing the conventional equation, so what should be the conventional chloride?
Yeah.
Cl,
Myself.
3.
Cl3. And it says solution. As soon as you see solution, you should say what?
Aqueous.
They make a video. Whatever.
And we're making, on the other side,
We're making magnesium chloride.
magnesium chloride.
And it's a.
And what is, how many chlorines are in magnesium chloride? Okay, is that solid, liquid, gas, or aqueous? Aqueous.
And then it's gonna be iron in there, plus iron. And that's a solid.
balance. Okay? Okay, so that would be our conventional equation. So now let's do our total ionic.
Magnesium.
Oh, yeah, we should probably balance over. Yeah, we should probably balance it before we get started. So. Okay, is it balanced? What do we need to do to balance it? That gives me 2 iron, 6 chlorine.
Out of 3, or no, out of 3 to the product, they all have this, or?
Oh, and
So then. Here, and then I need to put. Okay, so now it's balanced. Right? Everybody agree?
Yeah.
Oh, let me, I'm so mean.
Yeah, just a little bit.
What is headline listening?
You may have spoke too soon. Okay, so the total ionic equation.
Sorry, so it's gonna be magnesium.
Okay,
Oh, but I forgot the 3. Oh. Plus,
oh, it's gonna be.
oh no. Oh. Don't you have to add the charge on the?
I don't even think there's.
You have to add the charge.
okay, so then how, to what?
Plus the magnesium, plus 2.
No, because magnesium is a solid, it's an element, right? If it's an element, if it's a solid, it's an element. You don't need a charge on it. It only becomes charged when it's an ion. Is it an ion? No, it's a solid, okay? So
Also,
by itself, it's an element,
so then we'll add
unless
the
you're specifically told otherwise. What was that?
plus 2 iron,
Plus 2 iron.
and then
Does that have the charge?
that's gonna have the charge.
It's gonna have a charge. What's gonna be the charge on it?
3.
3. Plus. Bunch of chlorine. I have 6 chlorides, that's right. Now it's an ion, right? So let's go be the charge on it. 3.
Yes.
Sure. There's 3 of them. What's the charge on magnesium?
2.
How many chlorides do I have?
2. Oh,
6 chlorides. Okay. Since it's solid, it goes down the way it is. So who are our spectators?
well, chloride, no? Oh. Oh, 6.
6 chloride. Is that it?
Chloride. Anything else?
No, because
Because they have, they're different.
That's right, because they're different forms. That's a solid, this is aqueous.
Yeah.
That's aqueous, this is a solid, right?
Yeah.
So they're different. So at the end of the day, our net ionic equation is going to be Okay. That's right. Yep, that's right. That's right. Everybody got that?
Yeah.
Okay.
I was like second.
Get on, hurry.
Oops, sorry. I'll put it back on. Oops. Okay. It's not on this. Okay, there you go. You got it?
What the?
Okay. So this here is an example of a redox equation, right? You guys remember what redox means? We talked about it once before. We haven't talked about it?
I don't remember.
You don't
maybe I just
remember?
don't remember.
Okay, loss of electrons is going to be oxidation, Leo.
I think I wrote that down somewhere.
Yeah, it would
Oh, yeah, I
be.
remember.
Okay, so Leo. And then third, gain of electrons.
Oh my goodness, yeah.
Oh, yeah, I remember that.
So if you guys look at this, right? Magnesium is going from 0 to +2.
Uh-huh.
Is that going to be a loss of electrons or going to be gain of electrons?
You just gain some reduction.
Are you sure?
Oh.
Oh, no.
I'm going from 0 to +2.
Oh, so it's,
Loss.
yeah.
That's right. So this is Leo.
I forgot.
The only
For
time
a
it gains if
second.
it's negative, right?
That's
Yeah,
right.
yeah, it's the other way around.
So if it's gaining electrons, right? This guy's going from a +3 to 0. That's gaining electrons, right? So this is where. Okay. So reduced, iron is getting reduced, magnesium is being oxidized. Okay. Okay. I think I have a question on it. I wonder if I took it off. I think it's on this exam. One that you guys are doing.
With oxidation reduction.
It is on there? Okay. Okay, so let's do it. Actually, we'll do this one. This is fine. It says an iron nail is dropped into a solution of hydrochloric acid. Okay, so what I want you guys to do is I want you to write the conventional equation. Then I want you to write the total ionic, and then yeah. And here's the hard one. You guys got to figure it out on your own, right? You got to figure out the products.
Give us time.
Then I want you to tell me what oxidized and so that's, I have 30 minutes. to do that. That's-
Oh, yeah.
But there's an iron dropped into. Combined, so the iron plus the solution, which is hydrochloric. So.
Is it a solid?
Yeah. They used to make it.
It would be HCl, not with the. Same with the other one.
At least hopefully.
In the static?
And then I already said, anything that we don't cover. we don't get to.
So it's hydrogen.
It's a solid though. Yeah.
It won't hurt you. It'll just happen. Yeah, you won't be that.
Kind of it is.
Isn't it balanced now?
Okay, ready? Okay. Iron nail.
Iron.
Iron. Okay, so what is the symbol for iron again?
Fe.
Fe.
And it's a nail, so it's
Solid.
solid gas. And it's reacting with
With the hydrochloric. Oh, it's, yeah, hydrochloric
HCl.
acid. Aqueous.
this. And we're making
Or making the.
Into hydrochloric acid. So they're mixing with, right, the iron and the hydrochloric.
what type of reaction is this?
Well, it's not gonna dissolve, so it can't be aqueous.
With
A
this.
gas.
We're making a gas. So who's gonna make the gas? Who's gonna be gas? Hydrogen, that's right. Single replacement. So in this case, iron is replacing the hydrogen.
Oh.
So iron chloride. As you FeCl3. I think it says 2 on your thing, but it should be 2. Iron's preference when it's with chloride is to be
And the H2 would be the gas, right?
H2 would be the gas. Okay, so. Okay,
Balance.
so the balance, what do I need to do to balance it?
Well, first we gotta fix it.
Yeah,
Put in there.
put my line, okay. H and B. C.
Yeah.
Okay,
Well,
so right
yeah.
here we have 1, 1, 1. Over here, how much you get? 1. I need a 3. Okay,
You just made it odd.
so I have 3 hydrogens over here, 2 hydrogens over here.
Yeah, 6 in the
I need
HCl.
6. Okay. Okay. It's good. Okay, so then our total ionic equation. Solid. Now it's together, right? Can't be different parts. gas, you need alone, right? Solid, liquid, gas.
It's
It's a charge.
Charge,
No, CL is always gonna be -1, right? Okay, spectators.
6Cl.
The 2Fe.
That's it.
I think that's it.
Okay, Fe is not because it's different, right? It doesn't have a charge on one side and the other side has a charge. Okay, so then my net ionic equation. Okay, questions, concerns? Cash? Kool-Aid? Kool-Aid.
Oh.
Why change it up?
Why change it?
I gotta keep you on your toes, right?
We changed it up.
I know, the Kool-Aid.
Ain't you guys in the habit of being, routine, right? Yeah, I gotta keep you on your
It's all
toes.
credit.
And another layer, you guys ready for the next layer?
No way.
He asked for it, he was already asking.
Out of school.
Okay,
You can use the schools.
so what are you guys thinking of the class? You like it?
Yeah.
I wanna go home.
You wanna go, you can't go home. Yeah.
I think I took more ibuprofen and Tylenol during the class.
I totally read in this class. Emotional.
It is an emotional roller coaster.
Heck yeah.
You guys
I
got,
think
you have a
I've cried-
love hate for it. Yeah.
I think I've cried more for this class than any other class I've had.
Really?
Oh,
Yes.
have you seen that?
I took stats in high school and I had a full mental breakdown. I literally cut my hair for that. Yeah.
You're
I didn't even have a
so
wig.
long. If you have somewhere to go, you ain't fucking going. Because the equations for stats, they are so long.
One more, make sure you guys have a good grasp on this. And
Yeah.
then we're gonna move on to something else. This is the fun part, actually.
Oh.
Yeah.
Very crucial for your exam.
Oh, barely a passing.
I wish
You took it too long.
I think so. I took it in Texas.
It's just, they need to put stuff, they just
Oh, I
have.
need the paper. Like, what is this? Forgot about this.
The stuff kind of like, I understand, and then it's out of the way, I have to understand that.
And so if you guys, you look at it for me and then look at YouTube, then you're like, ah.
Yeah.
Okay, you got this, right? So you know the drill. And if you guys can tell me what's, oh, you have to tell what we produced. You guys can do it for this one. I feel like you want to go home.
I feel like I understood it at the beginning and then.
I think I can
crash.
Oh, that was one more crap.
I know, and you come back.
I then needed to just do the front.
Go ball.
Catherine said it's cool.
I'll be in class Monday, but I'll be in class Tuesday.
Yeah. Well, final section.
Oh, yeah, it's in that.
So,
What's on there?
I'll bring the touchy.
we were going to celebrate.
I don't know. I'll put one. Where are we gonna put the?
No, but where are you gonna put it? I don't know. why we should have it.
For organic.
So you're gonna tell me I'm
Was not that hard.
Like a salad.
That most of them-
That's my garlic salad.
Studies are very, very outdated.
required, or is it required?
I don't know.
Why don't you read it?
Why'd you-
Oh, yeah.
I'm gonna put salsa too. Bet. Like spicy, like it's good. It's good spicy.
So you guys are doing really badly.
It's like chocolate we put on the gas plate.
If you guys are doing good, then you can get funding to help others.
Like, it's not like we have.
My goal is right now,
It's right here. It is, but like, it's over, like, it's good, and then there's this. It's because my grandpa gets. Yeah.
Like, so are you gonna have taco meat or I don't know?
But they have two.
Are you bringing taco meat or tacos?
No, it was Isaiah.
Oh, that one? I thought he was it. Cause that's what he called him. Didn't Dr. Henry call him that earlier?
Did he really?
No.
Yes, he did, cause he answered.
No, it's something about texting his girlfriend later. Something about
Oh, yeah.
No, before that.
I don't know.
I don't know.
Dr. Henry, go what?
What about?
Oh, Dr. Henry can listen to what he's gonna.
Oh, yeah, what are you bringing?
Food.
No.
Okay,
don't
so
say that.
you guys have to be more specific.
You didn't specify what kind of food.
You guys want.
What?
I'll take it.
What is
What do you
it?
guys
Say it.
want?
No, what'd you say?
Steak
Sambusa?
What is that?
Don't crazy.
I want a T-bone steak.
You have?
No, so I should know that. Are you bringing a traditional?
I'm bring, can I bring some raisin for our person?
What is that?
They have-
Oh, let's have a share.
I'm gonna put it on the side.
Oh, good. I'll make potato
What are you gonna
salad.
bring?
Ooh, yes.
I probably won't know what it is, but if you don't like it, you don't have to eat it.
Okay,
Oh,
are you guys ready?
yeah, when you make me some rice, so it's my snack. You don't want snack?
Okay, so, it says the reaction occurs when a piece of steak is dropped.
He said he
is
bringing
dipped
tacos, hey?
into a
Let's go bring
solution of
tacos.
copper to
Taco,
hydrogen,
right?
right? The additional total ionic, net ionic. And then tell me if there's no redox is oxidized. Okay, where am I starting at?
So,
Who's Alex? Who's Alex?
and then if it's dipped, so it's solid.
She's making homemade macaroni and cheese.
And it's reacting with
That's
With
serious.
copper.
Oh, yeah, it is.
Oh, wait, copper nitrate.
Not with all that other shit.
Okay. And we're making.
See.
What if I want to make an equation?
I think that's like me and you.
Now, who's gonna replace who?
I didn't check.
Zinc is gonna replace the copper. Metal replaces metal, non-metal replaces non-metal. Okay, so. It's always gonna be zinc 2, because we know that it's zinc 2, so then how many nitrates will we need to balance that out? 2, right. Aqueous. And you're gonna ask me, how do you know that that's aqueous, right? If you look on the solubility table, did you guys look at the solubility table?
Yeah.
What did it say? It's soluble. Pretty much anything that's with nitrate is gonna be soluble. And so then we get copper.
Oh my God, train.
Salt. Okay, is it balanced?
No.
Sure.
Yes.
That's happening, they say, like, it's just like living.
Oh, it's not.
Okay. So is the balance, oh, man, that's pretty easy. Okay, so we're ready now. So let's do the total,
Weird.
the total ionic equation.
G and Q. Less copper.
He's like, good job.
All right, you're 2.
Plus N. Plus zinc. Plus N.
Plus what?
Oh, plus N. I know
Three.
three. Yeah.
How many? 2.
A quick.
A quick.
I use it.
Is it already?
She got me excited.
Okay, you guys, everybody got that, right? Who's our spectators?
2 and 03 haters.
Yes.
Oh, wait.
Okay, so then, all right, yes, ionic equation.
Just relax. No, wait, like.
Okay, so who's oxidized? Oxidized, loss of electrons.
Can you put on the screen? Oh, but isn't it gonna be the copper and the zinc?
Which one? Is it copper or the zinc? Which one?
Both, they both, right?
No,
Oh,
'cause
wait.
one is gonna be oxidized.
Oh,
the
okay,
other
wait,
one's
I
gonna be
understand
reduced,
now.
right?
Because it went from 0 to the 2+.
Okay, so the zinc is going from 0 to 2+, so it's losing electrons.
Yeah.
right? So that's gonna be our lead. Okay, loss of electrons, oxidation.
The copper.
And the copper is gonna be over. Speaking of that, I need to hire some tutors.
That's so funny.
Do you get paid for it?
Yes.
I think it's like $50 an hour.
$50 an hour.
It's 15. That's how it's-
I wish.
If it was $8 an hour, I'd be.
He's like, planet
Yeah,
I'm doing it.
He says-
Started this one.
Questions?
We put a picture on there.
You put the name on there.
At least we put
Okay,
someone started.
so now we're gonna talk about the activity series. Everybody got this down?
Yeah.
I'm gonna turn it off since I just let you look at it.
Yeah.
You gotta remind me, don't tell me at the end.
Why no, I didn't. That comes to 8 of us.
I need to take it in advance right now.
Oh,
Oh, okay, you guys haven't filled it out yet?
No, we were thinking like the last one.
Okay, so the activity series. Now, the way the activity series works is that it works in terms of hierarchy. Okay, so if we take a look, the block here, these guys are going to be more reactive with stuff, and they're going to be able to replace stuff that's beneath them. Okay, so for instance, lithium will replace everything that's beneath it. Okay, potassium will replace everything that's beneath it. So if we're doing a single replacement reaction, and this is when this happens, like in the case of zinc, you guys take a look at zinc and copper. Where is zinc on the hierarchy, on the activity scale? Activity series.
It's in the middle too.
Right here, right? So zinc is able to replace copper, right? But copper is not able to replace zinc because zinc is higher than copper. So zinc can replace copper, right? So if we had this equation the other way, where we had zinc nitrate. Gotta erase this up here, the yellow part. See what I'm talking about.
So good.
Oh, so.
Early, you got that time from someone?
Okay, so copper here, copper metal won't be able to replace zinc, right? Because zinc is higher on the activity series, right? Zinc can replace copper, but copper can't replace zinc. So here we have copper metal reacting with the zinc nitrate, right? In this case, we won't get a reaction. Okay, because copper is lower than zinc on the activity series. Okay, you guys get that?
Yeah.
So chemistry, there's a hierarchy in chemistry, right? And so metals can replace each other, but only if that metal is higher on the activity series than the other metal. Okay? So lithium can replace sodium. Lithium can replace gold. Silver can't replace any of the things that are above it. Okay? So I'm going to give you guys a test on this real quick. Okay? So I'm going to put 3 reactions up. And then I want you to tell me if there's going to be a reaction. And then you can kind of predict what it is, if there's a reaction. And if there isn't a reaction, you're just going to put NR. Okay? Right?
Those are its reactions, right?
And the rule of thumb is that except for iron, aluminum, silver, and cadmium, you're gonna get a +2 charge when you do single phase reactions. Transitional metals. Okay. Except, group 1 metals are always gonna be +1. You guys already know that, right? Group 2 metals are always gonna be +2, right? Everything else is gonna be +2 except for aluminum, iron, cadmium, silver.
Well, the first one is in on. For sure.
Okay, the first one is in on. Okay. What about the second?
I'm assuming there's a reaction.
Okay. Okay, so what would be our problem? Try, right? So then okay. Balance? Sure.
It's balanced.
Yeah, and you guys have a copy of the activity series on your handout in your packet. So if you open your packet, it should be in there. You actually have 2 copies. I like it so much.
We can see it now.
Yeah, so you can actually see it now. Okay, what about this last one? Is there a reaction?
Yeah.
You changed it. You put the wrong one.
What was that?
You put the wrong.
Oh,
Get those steps in.
yes, I gotta get that exercise in. Okay, questions? Okay, so now if you take a look at your activity series, it talks about hydrogen, right? So in the case of hydrogen, the way that if you look at that first group, it says if it's in water, steam, or if it's in an acid, right? Then you can exchange for hydrogen. Okay, in the second group, it says, the second block,
Says will replace H2 from steam or acid.
okay? And then in the third block,
Or replace H2 from acid.
okay, so those metals that are in there will replace H2 under those circumstances. If it's below H2, it will not replace H2. You guys will see that, right?
Yeah.
Okay, so that lets us know, again, there's a hierarchy. Here's where hydrogen is at. Hydrogen can replace all of these guys, but these guys can't replace hydrogen. Okay, these guys can replace hydrogen only when it's in an acid. Okay, these guys can only replace hydrogen only when it's in steam or an acid. These guys can replace hydrogen when it's water, steam, or an acid. Okay. Questions? Concerns? Yes.
Steam is considered a gas.
Yes, yeah.
Just-
Yeah, you put H2O. Okay, any other questions? Okay. Okay, but you guys see how that works, right? Starting to.
It's getting there. Like, it's like, but you're gonna add another layer.
Oh, of course, yeah. Okay, so we've talked about oxidation and reduction. This is an example of oxidation of organic material. Oxidation of organic material basically means that we're adding oxygen to the organic material. Again, there's a redox reaction that's happening, right? So that means that the organic material is being oxidized, and then whatever comes out is going to be produced. So the CO is going to be oxidized, this guy's going to be, so the hydrogen is water. Okay. Questions? Concerns? Okay, so you guys already know how to write these equations. When it's burning, when it's combustion, that always means that we have organic molecule plus oxygen yields carbon dioxide and water. All right. Piece of cake? Not a piece of cake? You don't remember it? You got it, and then you got to bounce it. Okay. So in the case of a double replacement and precipitation reaction, right? You guys have already learned how to use the solubility table. We just talked about that. So let's see if you guys can actually do it. So here's that solubility table that you guys have, right? So the rules of solubility, you guys can either use the solubility table or you can memorize the rules of solubility. If you guys are use the solubility table. Okay, but these are the rules of solubility. Group 1 metals are always going to be soluble. Okay. Nitrates, chlorides are typically always soluble. Right? And then the exceptions are always listed over here. So if you guys are in doubt, the exception is there. But they're all on that solubility. Okay. Okay, we're gonna do one more. So what I'd like you guys to do is the last thing I want to talk about is stability. There are certain cases where we have unstable products. One example of that is the formation of carbonic acid, and that's just H2CO3. So if we're forming H2CO3, that's not going to be stable. It's actually going to break down to CO2 and water. So you guys kind of see that here. The other thing is the formation of sulfuric acid. Now, if it's made a certain way, it'll work. I mean, the formation of sulfuric acid. That's going to break down to SO2 and water. And then the last case, my arrows. I think I always fix it and it's always screwed up. The formation of ammonium hydroxide. So formation of ammonium hydroxide is going to break down to ammonia and water. Okay. So questions, concerns, catch. Okay. So write the conventional total ionic equation, the net ionic equation, and the total net, total ionic conventional, total, and the net of this reaction. Okay. Do you have any questions?
Not right now. There were a couple things.
so we know it's gonna be-
They usually do it like.
Yeah. But,
Pages 9. Where is that? Oh, it's finished. So. Yeah, so the one was. Okay. Guys ready?
Oh, here we go.
Okay, so what's going to be my reactants?
So
Any two, three. Okay.
that's hydro.
Yeah, sodium carbonate and hydrochloric acid. It's on slide 36.
We know that this is unstable, right? So if it's unstable, it's going to be making
CO2 plus H2O.
Okay. Okay, so this is ultimately what we're doing. This would be our conventional. So then our net ionic equation is going to be okay, so the spectators are going to be
2Na plus
2Na plus
2Cl negative.
ionic equation. I mean net ionic equation. Questions? Concerns? Yes. Okay, so we didn't get a chance to go over chapter 10. Your test includes chapter 10. Chapter 10 is the completed part. We definitely have to go over that on Monday, but I recommend that you guys look over the notes. They'll help you get through. Okay. So since that's the case, I'm going to give you guys till Friday to turn in your third exam. Okay? So you'll have till Friday, not
This Friday, right?
not today, not this Friday,
Next Friday?
next Friday. Okay? To turn in the exam. So technically class will be already over. So you want to make sure that you guys do a good job on the exam. What's that?
Yeah.
It's just like, you know,
Monday. Monday. Okay, Monday's presentations, right? That's great. Fine.
What time was it? I don't know. You know,
we'll just bring it on Monday.
I'll see you guys. See you.
That brown stuff?
Huh?
That brown
Have a
stuff?
great day.
Sounds 5 feet.
Bye.